All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. So, guys, if you have not liked the session yet, I would want you guys to smash the like button because liking the session is extremely mandatory. Liking the session means marking the attendance. Okay, so everybody is supposed to mark the attendance as soon as possible. And then we will be starting the two chapters. We'll be starting these two chapters. I would say laws of motion and friction. Laws of motion and friction. That's what we will be discussing today. Okay. And if you have not studied these chapters before, you don't have to worry about anything because I'll be starting from the scratch. I'll be teaching you each and every single thing in detail. Every problem pattern we'll be discussing over here. Whatever the concepts you have, everything will be discussed. Okay? Great. Let the people come, let the people join, and we are starting the session accordingly. Okay. Yes. So, guys, when it comes to the laws of motion, it is an important chapter in the entire physics when it comes to the JEE and NEET. Okay, because we say questions are being asked from this particular chapter very frequently. So, let's get started. Okay, let's not waste further time. Let's get started. Now, my dear friends, before starting this laws of motion, I need to tell you something. That is what we call state of rest, and state of uniform motion. State of uniform motion. Uniform motion. Okay. State of rest or state of uniform motion. These are the two things that we have discussed already in kinematics. Once again, I'll be discussing this over here. Now guys, let's suppose I say I have a body over here. And this body is at rest, means it is not moving. Its velocity is zero. The body is at rest. Its velocity is zero. We say this state of this body is considered as state of rest. And sir, what is state of uniform motion? Let's suppose if you have an object and this object is moving with constant velocity. It is moving with constant velocity. Its direction is same. It is moving in this direction and it is moving with a constant speed also. We say this is called a state of uniform motion. This is called a state of uniform motion. Okay. If the body is at rest, if its velocity is zero, we consider it state of rest. If the body is moving with the constant velocity, we consider it state of uniform motion. Two basic things. Okay. Yes. Now, my dear NEET aspirants, let's suppose I ask you the simple question over here. What is that? Let's suppose if I am applying the force on this body, something like this, okay? If I'm pushing the body from the right side, and if I'm pushing this body from the left side with the same amount of force, the amount of force I'm applying from this side is equal to the amount of force I'm applying from this side. In that particular case, I would say net force on the body is zero. In that particular case, I would say net force on the body is zero. If net force on the body is zero, we say it will remain in the state of rest forever. It will remain in the state of rest. And if I say net force over here also is zero, so the amount of force I am applying from the right side as well as the left side, we say here also net force is zero. We say it will be moving, it will keep moving with the constant velocity, with the same velocity forever. Okay, two basic things. Now, my dear friends, There are two states of a body. We define two states of a body. The first one is what we call state of rest. And the second one is what we call state of uniform motion. State of uniform motion. State of uniform motion means when the velocity of the body is constant. Constant. It is moving with a constant velocity. Okay. Now, my dear friends, like over here, you have a mass. If it is at rest, means it's at a state of rest. Net force acting on this body is, we say, zero. It will remain in the state of rest forever. If this body is moving with a constant velocity, we say if you are applying the force on this side, same amount of force on the other side in the opposite direction, we say it will keep moving with the same velocity. It will keep moving with the same velocity. Yes. Now let's talk about inertia. Let's talk about inertia. Let's talk about inertia. Listen to me very carefully, my dear friends. Before starting this inertia, let me just give you a simple example. Let's suppose if you have an object over here. I have an object over here. And we said this object is in the state of rest. This object is in the state of rest. Okay. So it will take us 5 to 6 hours in completing the entire chapter. Okay. In 2 chapters, friction as well as this laws of motion. Now, my dear friends, listen carefully. Listen carefully. If the body is at rest, what I'm trying to say is that, let's suppose I say, is there any possibility that this body can change its state? It will come to the state of motion. It will come to the state of motion or uniform motion. If the body is at rest, is there any possibility that it will come in the state of uniform motion or motion? You say, sir, yes. What is that possibility? When you apply the force. When you apply the force. If I say don't apply the force, if we do not apply the force, is there any possibility it will change its state? It will not change its state if you do not apply the force on this body. It will remain in the state of rest forever. Now this tendency, this property of remaining in the rest forever, this is what we call inertia. This is what we call inertia. So basically, it wants to stay in the state of rest forever. Due to what? Due to what? Due to inertia. Due to inertia. Okay. Now, if you apply the force on this body, then it will change its state from rest to motion. So basically, you understand it like this. Because of inertia, inertia is a property of a body due to which it wants to remain in the state of rest if it is in the state of rest. Now guys, let's suppose we have an object over here. Let's suppose we have an object over here. This object is moving with a constant velocity. Or let's suppose you have a ball, it is rolling on the floor. Imagine there is no friction present on the floor. Floor is not applying friction on this ball. There is no air friction. We say, is there any possibility it will change its state from uniform motion? Do you think it will come to rest? No, sir, it cannot come to rest. Why? Because no force is acting on this body. So it is because of inertia. It will keep moving with a constant velocity forever. What I'm trying to say is that, listen carefully. Because of inertia, if the object is at rest, it will stay in the state of rest forever. If the object is moving with constant velocity, it will keep moving with the constant velocity forever until and unless some external force is acting on the object. So because of inertia, my dear friends, it remains in the same state. So inertia is the property due to which a body stays in the state of rest or in the state of uniform motion. Now guys, let's talk about over here. See. It is the inherent property of an object by virtue of which it wants to continue its state. So it's the property of a body due to which it wants to continue its state. Let's suppose if this object is at rest, we say due to inertia, it will remain in the rest forever until and unless somebody comes and applies force on this particular object. And this object, if this is moving with constant velocity, we say due to inertia, it wants to continue its state of uniform motion until and unless someone comes and applies the net external force and changes state. Please tell me in the chats if this is clear. Please tell me in the chats if this is crystalline clear. Then I'll give you one more example so that it will be more clear to you guys. Tell me guys, if this is crystalline clear to each and every single student. That's great. That's great. That's great. Now guys, have you ever experienced this? Let's suppose you are inside, you are inside a bus. This is a bus. This is a bus. Okay. This bus is at rest, let's suppose. Okay. Now, if the bus suddenly, or if let's suppose this bus is moving with some velocity. You are in a bus is moving with some velocity. And if the bus suddenly applies brakes, the person inside the bus, what do you feel? The person inside leans forward due to the inertia. Guys, let's suppose you are inside the bus. Bus is moving with some certain velocity. Now bus is applying the brakes. So it is changing its state from state of motion to state of rest. Now, due to this, the person inside leans forward. Why? Because of inertia. Because this person, if the bus was moving with certain velocity, it was in the state of motion. So this person was also in the state of motion. So when bus applies the brakes, it changes its state. So now this person was in the state of motion. So it wants to continue its state. If it was in the state of motion, it wants to continue its state. That is the reason, my dear friends, the person leans forward because of inertia. Due to inertia, it wants to continue its journey in the forward direction. I hope this example clears each and every single doubt of this. And we say inertia is proportional to mass. More is the mass of an object, more is going to be the inertia. More is the mass of an object, more is going to be the inertia. More tendency it will have to stay in the state of rest or state of uniform motion. Okay. We say it cannot be measured because it is not a physical quantity. It can be compared. It is not a physical quantity. I hope you got the proper feel of inertia. So basically, if an object is in the state of rest, it wants to continue its state. Due to inertia. If an object is in the uniform motion, it wants to continue the uniform motion due to inertia. Okay. If the person inside the bus, if the bus applies brakes, or if the bus is at rest, now suddenly it starts moving. In that particular case, you feel that jerk in the backward direction. Why? Because you were in the state of rest, and due to inertia, you wanted to continue that state. Okay. I hope this is crystal and clear. Now guys, let's move on to the Newton's first law of motion. Newton's first law of motion, we call it law of inertia also. See guys, let me make you understand. Ignore this as of now. Let's suppose you have an object over here. And this object is at rest. Let's suppose this object is at rest. Okay. I say this object will stay in the state of rest forever, until and unless some net external force acts on it. If I say, sir, if you apply the force on this one in this direction, if you apply the force on this one in this direction, two equal and opposite forces, we say net external force in this particular case is 0. So we can say it remains in the state of rest forever. So if there is an object which is at rest, okay, and some external force is acting, but net external force is zero, we say it will remain in the state of rest forever. So when will it change its state? If you apply the force, we say, if let's suppose you are applying 10 Newton and this is 5 Newton, so 10 minus 5 is 5. So we say net external force is not zero in that case. Okay. So now, my dear friends, let's suppose if I say there is an object, it is moving with the constant velocity. And net external force on this is zero. Net external force is acting, but I would say net external force acting on this object is zero. We say it will keep moving with the constant velocity forever. Okay. Now, my dear friends, what does Newton's first law say? Newton's first law says that if an object is at rest, it will remain in the rest forever. It is like inertia only, until and unless some net external force acts on it. If an object is moving with a constant velocity, it will keep moving with a constant velocity forever, until and unless some net external force acts on it. Now see, everybody wants to continue its state of rest / uniform motion until and unless it is acted upon by some net external force. So until and unless you apply some net external force on that particular object, then only it is going to change its state. It is like we say law of inertia. Please tell me in the chats if this is crystalline clear. Everybody out there, guys, tell me if this is crystalline clear. With the fire emojis. And if you have not liked the session yet, I would want you guys to smash the like button. Everybody out there, because liking the session is extremely mandatory. Okay. Yes. That's great. That is absolutely great. Now, guys, take a look over here. Let's talk about the force. Let's talk about the force. Now, guys, everybody knows that. What is this force? We say force is something due to which an object changes its state. Let's suppose this object is in the state of rest over here. If I say I want to change its state from rest to motion, so what will you do? You'll apply some force. So force is something due to which an object changes its state from rest to motion. Okay. And from, if the body is moving with the constant velocity, it can change its velocity. It is due to the force. Simply, if you are pushing something, means you are applying the force. Now, guys, there are variety of forces that we need to discuss in this particular chapter. That is, when we talk about the forces, when we talk about the different types of forces, we say there are fundamental forces. There are fundamental 4 forces. First one is gravitational force. Then you have electromagnetic force. Then you have strong nuclear force, and then you have weak nuclear forces. These are the 4 fundamental forces. Okay. Gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. Now, my dear friends, when it comes to this strong nuclear force, weak nuclear force, that we'll study in the modern physics in the upcoming time. See, but the forces that we need to discuss over here, these are the derived forces, means these are the forces like this weight force. Weight is basically the gravitational force. Okay. Like this normal reaction, tension, these are the electromagnetic in nature. Now, my dear friends, listen to me very carefully. So in this particular chapter, we will have to discuss these particular forces, like derived force means weight forces, normal force, tension, friction, not this buoyant force. This we'll see in the another chapter, not this viscous force, but the spring force. So 1, 2, 3, 4, 5. These 5 forces we need to discuss in this particular case, in this particular chapter. So fundamentally, there are 4 categories of forces. These 4, and these belong to these categories only. Okay. Now, in this particular chapter, we have to understand weight. We have to understand normal reaction, tension, friction. We say spring force. These forces. I hope this is crystal and clear. First and the foremost thing, let's understand what is this weight. What is this weight force? What is this weight force? Now, guys, see, weight force is simply, this is a gravitational force. This is a gravitational force. Now, let's suppose, everybody of you might have heard, let's suppose if I say I have an object over here. We say this earth, this is placed on the surface of earth. This is placed on the surface of earth. If I ask you, will this earth attract this object towards itself with any force? You say yes. What is that? That is what we call mg, gravitational force. And this is what we call the weight force. That force with which earth attracts some objects towards itself. With which earth attracts the objects towards itself. Now guys, let's suppose you have an object over here. Let's suppose you have an object over here. Its mass is m. It is placed on the surface of earth. Okay. We say a force will act on this due to the earth. That is what we call m into g. So this W is equal to m into g. This weight is equal to m into g. This is force due to the earth on this particular object. Guys, please tell me in the chats if this is crystal and clear. Please tell me in the chats if this is crystal and clear. So this is the force with which earth attracts the objects towards itself, towards its center. And let's suppose, my dear NEET aspirants, if let's suppose you have an object something like this. If let's suppose you have an object something like this. Its mass is m. And let's suppose this is placed at an inclined, it's placed at an inclined plane. We say, sir, on this object, we say force is acting in the downward direction. We say towards the center. So center of the earth, that is what we call m into g. And one more important thing I just want to say, my dear friends. I have told you previously, force can be, a vector can be resolved in 2 components. This vector can have it will have 2 components. First one is this, second one is this. If this angle is theta, we consider this angle also as theta. Now guys, this is mg, this is theta. So this component is going to be mg cos of theta. And this component is going to be mg sine of theta. I hope this is crystal and clear. I hope this is crystal and clear. Next you have normal reaction. Okay, next you have normal reaction. Listen to me very carefully, my dear NEET aspirants. We say, let's suppose you have got a table over here. There is a table. Okay. There's a table. And we say, on this table, you're placing an object. You're placing a box. There's a box. Now, my dear friends, whenever 2 bodies come in contact with each other, like this box is placed on the table, the surface of this table is in contact with the surface of the box. Whenever 2 bodies come in contact with each other, they apply a push-based force on each other. That is what we call normal reaction. So basically this table is going to apply the normal force on this one, that is N. And similarly, this box is also going to apply the normal reaction on this table, that what we call the N dash. And this N dash is equal to N. Whatever this table is going to apply the force on the box, same amount of force this table will be applying on the box. We say N dash is the normal force on the table due to the box or due to the block, and N is the normal force on the box due to the table. Okay. And one more important thing. Let's suppose, my dear friends, on an inclined plane, let's suppose you have got an object over here. Like here. See guys. We say this object, it is having the mass m. It is in contact with this surface. We said this inclined plane is going to apply the normal reaction on this one. Similarly, this block is going to apply the normal reaction on this inclined plane, that is N dash. And one more important thing I just want to say over here. Guys. Let's suppose there's a table over here. On top of this table, you have placed a box, that is M. Now, could you please tell me what are the forces acting on this block? You say, sir, in the downward direction, it is mg due to Earth. And due to this table, it is going to apply the normal reaction in the upward direction. Now, tell me one thing. Is this block which is placed on the table, like this pen is placed on my hand. On this pen in the downward direction, I would say mg is acting. Due to my hand, because of my hand, it is applying the normal reaction on this pen in the upward direction. Now tell me, is this pen moving in the downward direction or is it going up? Sir, it is at rest. It is not going down. It is not going up. So can I say in that particular case, this upward force will be equals to the downward force? Exactly, sir. 100% correct. Because the block is not doing any sort of motion. So that's why we say upward force will be equals to the downward force. Like here. See guys, if I say this is a block over here, its mass is m. We say this is mg in the downward direction and this angle over here is theta. Can I not say this will be also theta and this will be what? That is mg cos theta. Absolutely, sir. If this is mg cos theta, this component in this particular case is going to be mg sine of theta. Now guys, tell me, on this block, due to the inclined surface, don't you think normal reaction will be in the upward direction? Yes. And normal reaction will not be like this. Keep that thing in your mind. It will be like this. It is always perpendicular to the surface. If this is the surface, this is going to be the normal. If this is the surface, this is going to be the normal. If this is the surface, this is going to be the normal. Always makes 90. So now tell me guys, in this case, is the block going up like this or is it coming down? Sir, it is not going up, it is not going down. So we say n will be equals to mg cos of theta in this particular case. Please tell me in the chats, how many of you understood this? Please tell me in the chats, everybody out there. Guys, tell me, is this clear? Is this clear? With the fire emojis. So it's a push-based force. It's mentioned over here. It's a push-based force. Means this table is pushing the block in the upward direction. Similarly, this block is pushing the table in the downward direction. And. If two bodies lose contact, see guys. These two hands, they are in contact with each other, so they apply the normal reaction on each other. If they lose contact with each other, we say normal reaction will become 0. Okay? Yes. Sir, how you make mg cos theta a? If I say, let's suppose this is mg, this is any force, and if this is theta, this component of this force will be mg cos of theta. Why, sir? Because if you consider this theta, then this component will be cos, and this is going to be sine. Now, if let's suppose this is a, and you are considering this as theta, then this component will be a cos theta, this will be a sine theta. It depends which angle you are considering theta. If you consider this as theta, then take this as cos component. If you consider this as theta, then take this as cos. That's how I take cos. This is what we have studied in the vectors previously. Okay. Now, my dear friends, you have got a tension force. You have got tension force. I'll be showing you all the problem patterns, whatever you have over here. Pulley, woolly, everything. Now, guys, let's suppose you have, this is a ceiling over here. Okay. And there is a rope connected to the ceiling. There's a ceiling and there is a rope connected to the ceiling. Okay. And then we have connected a block with this rope. And then we have connected a block with this rope. Now, my dear NEET aspirants, if I ask you the simple question over here, is there any force acting on this block in the downward direction? Its mass is m. You say, yes, sir, that is mg. Okay. If mg is acting on this block in the downward direction, why isn't this block going down? Why? Sir, maybe because some force will be acting in the upward direction, and that is what we call tension. That is what we call tension. So here, tension is balancing this mg. That's why the block is not going down. And this tension is actually created in the string. So whenever you have a string, we say there is tension. There is tension. Like you have this rope over here. We say tension is present in the rope. Okay. Okay. So it is because of this tension, the block is not going down. It is not falling down. And here we say this tension will be equals to mg. Why? Because the block does not go down. It does not go up. That's why we say upward force will be equals to the downward. Okay. Yes. Yes. Now, my dear friends, it is a force which is created in a string. It is a force which is created in a rope in a string. Okay. It acts away from the point of contact. What is point of contact? Guys, this is the point of contact. So it is always away from the point of contact. Now guys, here this is another point of contact. So here tension will be something like this, away from the point of contact. Oh. Now guys, one more important thing. We say if the string is same, then tension is same. Like. Let's suppose I say I have got a block over here. There is one more block over here. Tell me one thing, guys. In this particular case, this is rope 1, string 1, and this is second string, another string. It is not the same string which is going from bottom to top. These are the two different strings. In this particular case, we say tension here, it will be T1. Tension here, it will be T1. In this rope, tension will be same. But in this rope, tension is going to be different. Here, tension will be T2. So here, tension will be T2. Array, sir. Because when rope changes, tension is going to be different. Like, let's suppose, if I say there is a pulley, something like this. So you have a block in this something like this. You have another block in this, something like this. Now tell me, if you take a look at the string, sir, it is the same string in this particular case. So tension is going to be same. So if I say tension here is T, so here also it will be T. Move to the other side. Here also it will be T. Here also it will be T. I am not mentioning T1 and T2. I am mentioning T and T only. Why? Because as long as the string is same, we say tension is going to remain the same. Please tell me in the chats if this is crystalline clear. Everybody out there. Tell me guys quickly if this is crystalline clear. If the string is same, tension is going to remain the same. If string changes, we say tension changes. Okay. Tell me guys. That's great. Then you have, I'll be showing you all the problem patterns or tension or on normal reaction, whatever it is. First, let's understand these category of forces over here. Then you have the spring force. Then you have the spring force. See, guys, what is this spring force all about? Let's suppose, let me show you here. Let's suppose you have got a block. This is a spring over here, and there is a block connected to the spring. There is a block connected to the spring. There is a block connected to the spring. Now, if I say you are applying some sort of force on the spring in the outward direction, you are elongating the spring with some force. We say this block will reach over here. Yes. Now, don't you think that the spring is going to create some sort of restoring force? It will try to bring the block back. So we say that restoring force in the spring, that is what we call the spring force. That is what we call the spring force. Okay. Now we say this spring force is proportional to x. X means the displacement that you have done. Okay. Now guys, see. If you are elongating this block in this direction, okay, we say force, if the x is in this direction towards right, force will be opposite. So I would say F is proportional to minus x. So force and displacement are opposite. Replacing this with a constant, we say F is equal to minus k times of x. This is what we call the spring force. It is that force due to which a spring restores the body, restores the block, okay, to the original position. And we say, if you guys, let's suppose there is this spring and there is this block. If you are pushing the block something like this, if the displacement is done towards left, we say this spring will push it back. This spring will push it back. See here also, we say this force is opposite to displacement. That's why I'm putting the negative sign over here. Force will be always opposite to the displacement in this particular case. Now guys, take a look, see what is mentioned over here. If we elongate a spring, if you elongate this spring, okay, by x, a restoring force will be developed. A restoring force will be developed called spring force. That is what we call the spring force. And this spring force is, we say, minus k times of x. Negative sign means if you are elongating in this direction, force will be opposite. If you are compressing the spring, force will be opposite. Where k is called the spring constant. Where k is called the spring constant. And k defines the stiffness of the spring. Like. Let's suppose you have a spring of cycle and you have a spring of car. Car spring, cycle spring. Which one is difficult to elongate? Cycle spring or car spring? Sir, car spring. Why? Because the value of k, car, that is having this spring. That is having, I would say, the stiffness of the spring. Value of k for the car spring is large. So k defines how stiff the spring is. How difficult it is to elongate and compress. That is defined by this. That is defined. It depends upon the material. It depends upon the material. Okay. Like we say, case of elongation. If let's suppose you have two masses over here, you're elongating these two masses. We say spring is going to basically pull it back. Spring is going to pull it back. So this is the restoring force in this particular case. Okay. Now, my dear friends, if you are compressing these two blocks, the spring is going to, we say push it back. We say this is what we call the spring force. And spring force is always towards the mean position. Compressing means you are compressing, elongating means you are elongating. If I say you are elongating this, elongate this. So spring force will be inwards. If you are compressing, spring force will be outwards. Please tell me in the chats if this is clear. Tell me, guys. Is this clear? When compressing, then what? SYN. What is that? What is SYN? Let me sir, already I have taught in basic mathematics as well as in vectors. It will be always negative. It will be always negative, even if you do the compression. See. If you are compressing, what does compression mean? Compress the spring. So means you are pushing it in this direction. So this will be the displacement towards left. Now this spring will apply the restoring force, spring force in the opposite direction. This and this is opposite. Here also it is going to be minus k times of x. Here also, because force is always opposite to displacement. Now, my dear friends, FBD, that's what we call the free body diagram. What does free body diagram actually mean? See guys, let's suppose if I am saying you have got a block over here present on the table, its mass is m. I am asking you to plot its free body diagram. See, there are points that you need to follow. See. What does it say? In order to make FBD or free body diagram, we should take that body, separate it from the system. System means this entire thing is what we call the system, table plus this block. Separate this block. If I say make the FBD, free body diagram of this block, separate it from the system. Yes, sir, I am separating this from the system. Okay. Identify all the forces acting on the body. Now guys, what is the force acting on this in the upward direction? Normal reaction. What is the force acting on this in the downward direction? Mg. So identify the forces, that is normal reaction, and in the downward direction it is mg. Okay. Then represent the forces in a vector form. This is in the vector form. See. Then apply Newton's laws. We'll apply the Newton's laws also. Then we can say this upward force will be equals to the mg. That's it. Like. Let me show you the question over here. Draw FBD of these two blocks. Draw FBD of these two blocks. See guys. You have first, I would say over here, FBD of which one? I would say 2 kg. What is the first thing we are supposed to do? We say separate this from the system. So I'm separating this from the system and it is 2 kg mass. Then identify the forces acting on the body. We say in the downward direction, it is m into g. M is 2, g is g, 2g. And in the upward direction, what is the force acting over here? That is tension T1. Now, if this block is at rest, can I not say upward force will be equals to downward force? T will be equals to 2g. Value of g, we always take 10, acceleration due to gravity. So this T1 will be equals to, we say 20 Newton. Array, sir. Crystal clear, sir. Let's make the FBD of this. I would say FBD of, this is 4 kg, of 4 kg block. FBD of 4 kg block. FBD of 4 kg block. So I'll make it over here. This is 4 kg. Now tell me one thing, guys. What is the first thing we guys are supposed to do? So we say we represent this with a point mass, or you say separate this from the system. And then what is the force? Forces acting on this body. In the downward direction, we say, sir, it is T1. And also mg will act, that is m is 4 and g is g. And in the upward direction, you can clearly say, sir, this is tension T2. This is tension T2. Now guys, the block is at rest. Don't you think upward force will be equals to the downward force? So you can say T2 will be equals to, that is 4G plus, I would say, T1. Because these two forces in the downward direction, this is in the upward direction. So this is T1. So this T2 is going to be 4 into 10 is 40 plus, what is the value of T1? That is 20. So T2 is going to be 60 Newton. I hope this is crystalline clear. I hope this is crystalline clear. Then let's suppose, find T1, T2 and T3. This is the question that you have. 3 blocks over here. 3 blocks over here. Now guys, take a look. First and the foremost thing, let's make the FBD of 5 kg. I would say FBD of 5 kg. Let's make the FBD of this block. So this is 5 kg over here. We say in the downward direction, what is the force acting? That is 5G. In the upward direction, what is the force acting? That is tension T1. Guys, if the string is different, tension will be different. Here tension is T1, here tension is T2, here tension is T3. Okay. Now tell me, can I not say this T1 will be equals to 5G. 5G means 50. So T1 will come out to be equal to 50 Newton. Crystal clear, sir. Then guys, if I talk about this, FBD of I would say 2 kg. So I'm making over here this 2 kg. In the downward direction, what is the force acting? That is 2G. In the upward direction, what is the force acting? That is T2. T2 upward, 2G downward. And one more force, that is T1. This T1 is also acting. So can I not say this upward force T2 will be equals to, we say T1. We say that is T1 plus I would say 2G. And this T2 will come out to be, what is the value of T1? That is 50. We say plus this is 20. 2 into 10 is 20. So this will come out to be 70. Let's suppose, my dear friends, if I say FBD of this block, FBD of, I would say this 4 kg. So I'm making this 4 kg. Now, what are the forces acting on this body? First, in the downward direction, 4G, mg. Then you have this T2 and you have T3. T3 in the upward direction and T2 in the downward direction. Now, the block is at rest. Means upward force will be equals to the downward force. So T3 will be equals to T2 plus I would say 4G. So this T3 will be equals to, what is the value of T2, my dear friends? T2 is 70 plus I would say 4 into 10 is 40. So that is going to be 110 Newton. Please tell me in the chats how many of you understood this. Quickly in the chats. Everybody. Quickly. Okay. That's great. Now, guys, let's move on to the next question. If the system is in equilibrium, sir, what does this equilibrium word mean? Guys. Listen to me very carefully. From now onwards, see. Let's suppose you have a block over here. Okay, you have a block over here. On this block, I would say force acting on this side is F and force acting on this side is F. This force is F, this force is F. And in this particular case, I would say net force on this system is 0. Net force on this system is 0. So we say the block is in the equilibrium. Okay. So if this is at rest, it will remain in the state of rest forever. This is what we call equilibrium. This is what we call equilibrium. If this block, if the net force on this block is 0, we say the block will be in the equilibrium. If this is at rest, it will remain in the rest forever. Okay. Now, my dear friends, let's take a look over here. So this system is actually in the equilibrium. Means this block does not go up, it does not fall down. This block does not go down, it does not go up. It is in the equilibrium. Now, guys, we are supposed to find the value of M in this particular case. See. First thing, if I ask you, is there any force acting on this in the downward direction? You say, sir, that is 4G. If I ask you, what is the force acting in this? That is T. This is the tension T. Okay. Now, guys, same rope goes till here. So don't you think here also tension is going to be T? Yes. And one more important thing, is if this is M, don't we say this is mg in the downward direction? If this is theta, guys, we say this component, this is going to be theta or 30. This will be mg cos 30. Yes, sir. And guys, this component is going to be, that is mg, I would say sine 30. Mg sine 30. Absolutely, sir. Absolutely, sir. Now, guys, tell me one thing. FBD. First, let's make the FBD of 4 kg. FBD of 4 kg. If we are making the FBD of 4 kg, this is 4 kg. What is the force acting in the downward direction? That is 4G. What is the force acting in the upward direction? That is tension T. Now, if the block is in the equilibrium, we say block in equilibrium. Now, what do we say? If the system is in the equilibrium, the force acting from the right side will be equal to the force acting from the left side. So we say in that particular case, this T will be equals to 4G, T will be equals to 40 Newton. Oh, sir, crystal clear. Now, guys, tell me. Can I not say, let's make the FBD of this. We say FBD of, we say this mass M. Now, if you are making this mass M over here, see. From the right side, what is the force acting tension? From the left side tension, from the right side, it is mg sine theta. So from this side, it is tension. From this side, it will be mg sine of 30 degrees in this particular case. Now, guys, can I not say, if the block is in the equilibrium, it is not falling down, it is not going up. So we say this tension will be equals to mg sine. So this tension will be equals to mg sine of 30. What is the value of tension? That is 40. And this is m. What is the value of g? That is 10. Sine 30 is 1 by 2. 2 1s are 2 5s are 10. 5 1s are 5 8s are. So m will come out to be 8 kgs. Please tell me in the chats if this is crystalline clear. Everybody out there, quick. Tell me, guys. Okay, that's great. Let's take a look at this question. Find the value of M1 if the system is in the equilibrium. Entire system is in the equilibrium. You guys are supposed to find the value of this M1. See guys, listen to me very carefully. Listen to me very carefully. First and the foremost thing, draw all the forces acting on the system. We say on the system in the downward direction, it is M1 into G. And in this direction, it is tension T. Now guys, see. It is the same string going till over here. And here also tension is going to be T. And here tension is going to be T. Here tension is going to be T. This is what we call pulley. This is what we call pulley. Now, one thing I just want to say in this particular case, guys. Let's suppose if this is a pulley, okay? If this is a pulley. Always remember one thing. If this is rope, this is another rope. In this direction, if let's suppose you have tension T, in this direction you have tension T, and here, let's suppose this is tension T dash. Always remember, when you consider the pulley, whatever is the force in the upward direction, same you will be considering the force in the downward direction. So this T will be equal to this T plus T, that is 2. Upward force is equal to downward force. Keep that thing in your mind. Let's suppose this is a pulley, something like this. In this direction, we say, let's suppose this is T dash. From this side, value of tension is 10 Newton. From this side, value of tension is 10 Newton. What is going to be the value of T dash? T dash will be simply 10 plus 10, that is going to be 20. Oh, sir. Crystalline clear. Now, guys, take a look. I'll make you understand. Now, if this is tension T over here, we say same tension will go till over here because it's the same rope. Now, guys, same. Here also T. And here also it is going to be T. Yes. Now tell me one thing. Everybody out there. Listen. We say this is 10 kg. In the downward direction, what is the force acting? That is 10 G. Now do one thing. Make the FBD of this body and make the FBD of this body. And guys, one more thing. See this rope. This is the same rope which is going till over here. That's why tension in the rope at every point will be same. Same tension. Cool. Now, my dear NEET aspirants, we said this is a different rope. Tension in this case will be T dash. Here, tension in this rope is going to be T dash. Now, make the FBD of this. If I make the FBD of this block, of this 10 kg block, FBD of, I would say 10 kg block. Listen carefully. If I'm making this 10 kg block over here, what is the force acting in the downward direction? You say, sir, that is 10 G. What is the force acting in the upward direction? That is T dash. So clearly I can say this T dash will be equals to 10 G. So this T dash will be equals to 100 Newton. This T dash is 100 Newton. Now tell me one thing, my dear friends. Now if this is T dash, so from the upper side, this is T and this is T. Don't you think as FBD of pulley, sir, we can make the FBD of pulley also? Yes. Now take a look at this pulley. You see in the upward direction, it is tension T over here. And in here also it is tension T. Okay. And in this downward direction, it is T dash. And what is the value of this T dash? 100 Newton. Now tell me, what did I tell you? This tension plus this tension means 2T must be equal to this tension, that is T dash. So this 2T will be equals to, we say 100 Newton. So T will be equals to 50 Newton. So value of this T is 50 Newton. Cool. Now make the FBD of this block, FBD of M1. Now guys, take a look. In the downward direction, it is M1G. In the upward direction, it is T. So can I not say this T is equal to M1 into G? This T will be equals to M1 into G. What is the value of T? That is 50 is equal to M1 into what is the value of G? That is 10. So this and this will cancel. M will come out to be 5 kg. I hope this question is crystal and clear. Please tell me in the chats if this is clear. Guys, tell me in the chats. Is this clear? Is this clear? Is this clear? Yes. Now, an important question that I want you guys to take a look. A uniform rope of mass m, a uniform rope of mass m, a uniform rope of mass m and length L. There is a rope over here. Okay. Its mass is m and its length is L. Sir, till now, these ropes, this rope, this rope, this rope, this rope, this rope, we were considering these ropes as massless ropes. Okay. We were considering these ropes as massless ropes. Now, my dear friends, ideal string. I'll just write a point over here. I'll just write a point over here. See, I'll mention in case of an ideal string slash massless string, tension at every point is same. If I say you have got, my dear NEET aspirants, take a look over here. If I say this is the mass over here in the downward direction, it is mg. We say here it is tension T. At this point, let's suppose this is TA. At this point, we say, let's suppose this is tension TB. At this point, we say this is tension TC. And if I say the string is massless, we are considering this as ideal string. We say in that case, whatever is the tension at A, same will be the tension at B, same will be the tension at C. Tension at every point we are going to say, take the same. Okay. But if the string has mass, like, what is mentioned in the question over here? A uniform rope of mass capital M. This rope, this string has mass capital M and length L is fixed from upper end. It is fixed from upper end. Vertically from a ridged support, then the tension in the rope at a distance X from the ridge support will be. Guys. It says that what is going to be the tension at this distance X from the rigid support, from this ridge support, if the length is L. My dear NEET aspirants, I told you, when it comes to a string which has mass, tension at every point will be different. We say here, tension is different at every point because string is not ideal slash massless. So if I say, I would want you guys to directly remember this result because I'll not derive it over here. I would say directly you remember tension at this point is going to be M divided by L. M is the mass of this. L is the length of this. Then we say L minus X. X is the distance at which you guys are supposed to find. And then we say into G. This is the tension in that particular case. I hope this is crystalline clear. Guys, please please tell me in the chats if this is crystalline clear. Everybody out there. Tell me guys quickly if this is clear. If this is crystalline clear. Tell me guys quickly. Now guys, see. Take a look. Find the tension and angle theta by the string if the system is in equilibrium. See guys, let's suppose you have got a system over here. This is the system. Okay. And there's a ceiling over here. And you have connected a rope. And then a block is attached to this particular rope. And you are pulling this rope with the force F. And this angle over here is theta. It is making the angle theta. Now this block is in the equilibrium. Equilibrium means you simply consider this at rest. This block does not move in the forward direction. It does not go up. It does not go down. It remains in the equilibrium over here. See guys, we are supposed to find the value of this angle theta. Okay. And we are supposed to find the value of tension T. What is the first thing we guys are supposed to do? You draw all the forces acting on the block. Now take this block. What is the force acting on this block in the downward direction? That is mg. Okay. And if this is a rope, we say in the rope you have got which force? Which force? You have got tension. That is tension T. If this is tension T, this is going to be, guys, this component. If this is theta, this angle will be also theta. If this is T, this is theta. This component is going to be T cos theta. And this component is going to be T sin theta. Okay. Now, my dear NEET aspirants, I'll make over here FBD. FBD of mass M. Let's make the FBD of this mass M. So I would say this is the mass M over here. In the downward direction, it is mg. So on the right side, what is acting? We say force F. On the left side, what is acting? I would say T sin theta. And in the upward direction, it is going to be T cos theta. T cos theta. Now guys, can I not say here, this T sin of theta will be equals to force F. This T cos theta in this particular case is going to be mg. Why, sir? Because the block is in the equilibrium. Upward force is equal to downward force. Right side force will be equals to the left side force. Now divide the two equations. T and T will cancel. Sin theta by cos theta. It is going to be tan theta. And it will be F. Just a second. So this is going to be T cos theta. Okay. This is going to be F. Okay. Now, what I can write over here, this T sin of theta will be equals to F. T cos of theta will be equals to mg. Divide the two. This and this will cancel. Sin theta by cos theta will come out to be tan theta. And this will be F divided by mg. Okay. And you can clearly say this theta will be, that is tan inverse of this F divided by mg. So this is, you were supposed to calculate the value of this theta. Now you are supposed to find the value of tension. Now you have to find the value of tension, this tension T. See guys, take the block. Let's find tension. Let's find tension. So take this block. If I'm taking this particular block of mass M, what is the force acting on this block in the downward direction? That is mg. Okay. What is the force acting on this block in this direction? That is F. And what is the force acting on this side? That is tension T. Then we have resolved this T in two components, cos and sin. Don't resolve over here. Keep it as it is. Now, could you please tell me, my dear NEET aspirants, if I ask you, what is the resultant of this force and this force? You say, sir, resultant of these forces will be something like this, under root of. Previously, I have told you, if you have two vectors at an angle of 90 degrees, we say in that case, resultant will be this force F square plus, I would say, that is mg whole square. This is going to be the resultant. Now, my dear friends, if you say the block is in the equilibrium, upward force is equal downward force. Right side force is equal left side force. Don't you think that this force must be equal to this force and this must be equal to tension? So this is the value of tension. Please tell me in the chats how many of you understood this. Guys, quick, tell me in the chats how many of you understood this clearly. Tell me quickly. And smash the like button if you have not liked the session yet. Quick, quick, quick. Quick. Tell me, guys. I hope this is crystal and clear. Okay. Let's suppose you have a question something like this. You have a question something like this. See, guys. See, guys. See, take a look. Let's suppose you have a spring connected over here and there is a block connected to the spring. Its mass is m. If I ask you find the extension in the spring, that is x. See. Guys. Tell me one thing. Is there any force acting on this block in the downward direction? Yes. What is that? That is mg. Yes, sir. mg is the force acting on this block in the downward direction. Yes. Now, due to this mg, don't you think we said due to mg, I would say spring will elongate. This spring is going to elongate. So it will create a restoring force, means it will elongate. X will be there. It will elongate. Okay. And when it elongates, let's suppose it elongates by distance x. Due to that, this spring is going to create the restoring force. Okay. That is spring force. We said on this block, is there any force acting in the downward direction? Yes, that is mg. Because of mg, spring will elongate. Okay. If spring elongates, we say in that particular case, spring will create the restoring force if it elongates in the downward direction, because this is the external force acting over here. Due to this, it will elongate in this direction. So spring will apply the restoring force in the upward direction. Okay. Now, if somebody asks you, what is the value of this elongation x over here? This is the question. Take a look. Whenever you have a question something like this, always do one thing. Replace the spring with the string. Replace the spring with the string. This is a technique, this is a trick to solve the questions. Now, sir, what you are trying to say is that you are saying replace this with string. So means then in the string tension will act. Yes, sir. Instead of this restoring force, you have to draw the tension over here. So in reality, this tension will be restoring force, and in the downward direction, it is mg. I hope you are getting me what I'm trying to say. If I say you have to find the value of x, how much is the, I would say, elongation in the spring? You say, sir, replace the spring with the tension. Okay, sir. In the downward direction, what is acting? Mg. In the upward direction, what is acting? Tension. So this tension will be equals to mg. Yes, sir. But this tension is actually restoring force, and this restoring force is k times of x. So I would write over here k times of x. This will be equals to mg. And this x will be equals to mg divided by k. Oh, sir, done, sir, done. I hope you got crystal clear feel over here. Is this clear? See guys, if I say find the extension in the spring, like over here, you have mass m, there is a spring attached. In the downward direction, what is the force acting? Mg. Here in the spring, we say it will create restoring force. Now I say replace the spring with the rope. Then find tension. Sir, I am replacing this with a rope, then find tension. So then find tension. Okay. Then, my dear friends, we say this tension will be equals to mg. Tension is equal to mg. Now, in reality, this tension is basically the spring force because you have replaced it. So it is k times of x is equal to mg. X is equal to mg by k. Array, sir, please show us the question. Take a look at the question. Take a look at the question. See, guys, find the reading of the spring balance and the value of k is given as 100. Okay, Newton per meter. This is the value of k in this particular case. Oh, is this clear? Please tell me in the chats, everybody out there. See, what is the first thing I'm supposed to do? See, guys, we say in the downward direction, I would say mg is acting. Okay, and we say from in this direction it will be mg cos theta. In this direction it is going to be mg sin 30. Mg sin 30. And because of mg sin 30, spring will elongate. So spring is going to create the restoring force in the upward direction. Now what I'm trying to say is that replace this with the tension. Replace this with a string. Now guys, see. Ladies and gentlemen, take a look. So you have got a block over here and there is the string connected. So this is the tension T. And in this direction, what is the force acting? That is going to be mg sine of 30 degrees. Now tell me, the block is in the equilibrium. Don't you think that this tension must be equal to mg sine 30? So this must be equal to mg sine of 30. But you guys tell me one thing. If you have replaced the spring with the rope, so then tension will be equals to spring force. That will be equals to k times of x. So here I'll be writing k times of x is equal to mg sine 30. What is the value of k? 100. And this is x. And this mass into 10, g is 10. Sine 30 is 1 by 2. 2 ones are 2, 5s are 10. 5 ones are 5. 25s are. Oh, is this clear? We are supposed to find the value of this x. Wait. Okay. So 2 ones are 2, 5s are 10. So value of, okay, what is the mass? Mass is also given as 5. Okay. So this is 100x is equal to mass is given as 5 into this 5. That is 25. So x is going to be 25 divided by 100. 25 ones are 25 fours are 1 divided by 4. Oh, is this clear? Oh, is this clear? Is this clear? Is this clear? Please tell me in the chats. Is this clear? I need the signal from every single student whosoever is watching. Guys, tell me quickly in the chats if this is crystalline clear. Give me the signal, then only I am moving forward. Let's take a look at this. Very good question. Find the extension in both the springs. You guys are supposed to find the extension in both the springs. See guys, first let's understand the question. We say on this block in the downward direction 2G will act. On this block in the downward direction 1G will act. Now see, due to this 2G, it is pulling the block in the downward direction, which itself is pulling the spring in the downward direction, means spring will elongate. It will create restoring force. So how much is the elongation in this spring? How much is the elongation in this spring? Take a look. What is the first thing we are supposed to do? Replace the two springs with the ropes. So I'll make it like this. So this is 2 kg, this is 1 kg. In the downward direction, it is 2G here, and in this over here, it is 1G. Okay. And guys, take a look. We say here, tension is going to be T1. Here, tension is going to be T1. And here, tension is going to be T2. Here, tension is going to be T2. Now, ladies and gentlemen, boys and girls, this tension actually means what? Spring force in this one. This tension T2 actually means what? Spring force in this one. So it is spring force in this. It is spring force in this. Ah, crystal clear, sir. Now let's make the FBD. I'll say FBD of 2 kg. FBD of 2 kg. Tell me guys, if this is 2 kg, in the downward direction, what is the force acting? That is 2G. In the upward direction, what is the force acting? That is tension T1. So can I not say this T1 will be equals to 2G? Yes, sir. And in reality, this tension is the spring force in this spring. So it is K times of X1. We call it X1 because here elongation in this spring will be X1. Elongation in this spring will be X2. Will be equals to 2 into G is 20. Value of K is given as 100. 100 into X1 is equal to 20. This and this will cancel. So X will be equals to 2 divided by 10. Oh, yes or no? Is this clear? That is 0.2. So X will be 0.2 meters. Okay. Now, guys, let's make the FBD of this one. We say FBD of, I would say 1 kg. So if I'm making this 1 kg over here, what is the force acting on this 1 kg in the downward direction? T1 and this is T1 and this is 1G. And what is the force acting in the upward direction? This is T2. Now, don't you think that in this particular case, upward force T2 will be equals to the downward force, that is T1 plus 1G? Oh, amazing, sir. Now tell me, this T1, what is the value of T1? That is 20, 2G. So this T2 will be equals to 20 plus 10, that is 30. Now in reality, this T2 is what? That is this spring force. So I would say this is K times of X2 is equal to, we say, sir, 30. So this over here is 100 and this is X2 is equal to, we say, sir, 30. 0 and 0 will cancel out. So this is X2 will come out to be, that is 3 divided by 10, that is 0.3 meters. Or tell me in the chats how many of you understood this. Okay, I'll tell the Jonathan, sir. Okay. Oh, how many of you understood this? Give me the signal in the chats. Momentum. Let's understand momentum. Let's understand momentum. See, guys, let's suppose you have a wall over here. There's a wall that is placed over here. Okay. There's a strong wall made of concrete. And there is a toy car. Okay. Small kids play with the toy car. And it is moving towards the wall. And there is a big truck. There is a big truck. It is also moving towards the wall. If I ask you the simple question, which of the two is going to break the wall or destroy the wall? Which of the two is going to break the wall or destroy the wall? Tell me, toy car or the truck? Which of the two has the tendency to break the wall? Truck. We say in order to break the wall, we say truck has, why the truck has tendency? Now guys, see. You say, see, take a look. Let's suppose it is going with certain velocity v. It is also going with certain velocity v. Sir, we know that mass of this is less. If it strikes the wall, it is going to do nothing. We say mass of this is large, it is going to break the wall. That is what you are trying to say. Okay, cool. Guys, see. If its mass is large, you are saying, sir, it is because of the mass it is breaking the wall. I say, no, it is not because of the mass. See, if I say you decrease the velocity of this truck, it is moving very slowly now. Now, if it is moving slowly, if it hits the wall, it is not going to do anything. It is not only the mass which is breaking the wall. It is combination of mass as well as velocity. When this truck has both large mass and large velocity, then only we say it has the capability to break the wall. Okay, here this has got less mass, but velocity is large. It is going to do nothing. So that's why, my dear friends, mass should be large, velocity should be large. Means combination of mass and velocity should be large, and that is what we call momentum. So it is basically momentum which is breaking the wall. It is momentum which is breaking the wall. In order to break the wall, both mass as well as velocity must be large. So it is the combination of mass and velocity which breaks the wall, and it is called momentum. Combination of mass and velocity is momentum. Like we say, this train is having a lot of momentum. Why? Because train has a huge velocity. Train has huge mass. If something strikes with the train, it is going to destroy it completely. Why? Because of momentum. Because of momentum. Okay. So that's why we say momentum means whenever a mass comes in motion, whenever you have mass, velocity, we say it is momentum. Its unit is kg meter per second. So truck here has large momentum because of large mass, because of large velocity. Now, there is a question which was asked in NEET 2022. There is a question which was asked in NEET 2022. And momentum is a vector quantity, by the way. The distance covered by a body of mass 5 grams having linear momentum of this in 5 seconds is. It says there is a body. Let's suppose there is a body. Okay, its mass is 5 grams and it has got a momentum of 0.3 kg meter per second. It has momentum 0.3. Oh, yeah, it is moving. Okay, how much distance it is going to cover in time t is equal to 5 seconds. Okay, there is a body, its momentum is given. In 5 seconds, how much distance it is going to cover? So we say distance is equal to velocity into time. Okay, because velocity is distance upon time, velocity into time. So time is 5 seconds, but velocity is not given, but momentum is given. We say momentum is mass into velocity. What is momentum? That is 0.3. Okay, and what is mass? Mass is 5 grams. Now guys, see, we say 1000 grams is equal to 1 kg. Okay, if I say 1 gram is equal to how much? 1 divided by 1000. Simple. If I say 5 grams will be equals to how much? That is 5 divided by 1000. If I say 10 grams equal to how many kgs, and it is in kgs, we say 10 divided by 1000. As simple as that. So mass over here is, this is 5 divided by 1000. Okay, and velocity we need to calculate. So this 3, we can say 3 divided by 10 is equal to 5 divided by 1000 into V. Okay. So this will be 300 divided by 5 is equal to V. V comes out to be 60 meter per second. So this is going to be, velocity is 60, time is 5. So displacement is going to be 300 meters. Oh, is this clear? Okay. Find momentum. Let's suppose if I ask you, there is an object, its mass is 3 kg, and this is the velocity. It's in the vector form, it's momentum. What is momentum? Momentum is simply, that is product of mass and velocity. So this momentum you can write as it is. What is mass? Mass is 3 kg. So this is 3, scalar quantity. And what is velocity? That is 2i cap plus 3j cap. So this momentum you can simply write 3 into 2 is 6i cap plus 3 into 3 is 9j cap. Even you can find the magnitude of this momentum also. That is under root of. How do we find the magnitude of a vector? Whatever is the coefficient of this I, its square, plus whatever is the coefficient of this j, its square. Okay, calculate the magnitude. Let's suppose you have this. You are supposed to find the momentum in this case. See guys, an object of mass 6 kg, it is moving with 20 meter per second at 37 degrees. See. We say this is, let's find velocity first. We say momentum will be mass into velocity. Let's find velocity first. See guys, if this is 20, this is 37, this component is going to be 20 cos of 37. This component is going to be 20 sine of 37. If this is 20, this will be 20 cos 37, this will be 20 sine 37. Now guys, tell me, I have told you so many times 37-degree triangle. This is a triangle, this angle is 37 degrees. This is a triangle of 37 degrees. Now guys, see, we say this side is 3, this is 4, and this is 5. Now sine 37 is perpendicular upon hypotenuse, 3 by 5. Cos 37 is 4 by 5. So this is going to be 20, cos 37 is 4 by 5. 5 ones are 5 fours are. So this will come out to be 16 I cap. Sir, why are you mentioning 16 I cap? Because this is in the x direction. So when a vector is along x-axis, we mention I cap with it. This is in the y direction. That is 20 sine 37. So this is going to be 20 into 3 by 5. 5 ones are 5 fours are 20. 4 into 3 is 12. So this is 12 j cap. Sir, why are you mentioning j cap over here? Because this is in the y direction. If a vector is along y-axis, we mention j cap. Now, how can you write the velocity over here? Velocity of this is, in vector form, it is 16 I cap plus, we said 12 j cap. Now, if I ask you, what is going to be the momentum? Momentum in this case will be mass into velocity. So momentum in this particular case will be, that is, mass is given as 6 kgs, velocity is 16 I cap plus 12 j cap. Okay. Now, this is going to be the momentum. Oh, tell me in the chat, sir, if this is clear. Tell me, oh, everybody, ladies and gentlemen, ladies and ladies, tell me. Next, you have change in momentum. Come on, I need the signal in the chats. If everything is crystalline clear, then only I shall be moving forward. Else, I am stopping the session over here only and I'm leaving. Okay. You guys also go home. Now, my dear NEET aspirants, let's understand the change in moment. Let's understand the change in moment. Okay. What is change in momentum? Change in momentum is final momentum minus initial momentum. Like. Guys, let's suppose there is a body over here. Its velocity in this particular case is something. Let's suppose it is VI. And here velocity is VF. Velocity of the, what is momentum over here? Mass into VI. What is momentum over here? Mass into VF. Now, is the momentum same or momentum is changed? Momentum is changed from VI to VF. If I say what is change in momentum? Delta P. You say final momentum minus initial momentum. Okay. That is going to be mass into final velocity minus mass into initial velocity. So take this mass out. This is going to be V final minus V initial. This is what we call the change in momentum. This is what we call the change in momentum. Okay. Let me write over here. Let me write over here. This is an object, its mass is m, velocity is vi. So when it reaches here, here velocity is vf. If I say what is the momentum over here, initial momentum, you say, sir, mass into initial velocity. What is final momentum? You say mass into final velocity. If I say what is change in momentum, you say final momentum minus initial momentum. You say change in momentum is final momentum is mass into final velocity minus mass into initial velocity. So this delta P will be, take this mass out. So this is V final minus V. This is how we write the change in momentum. Okay. Like there is an object over here. Its mass is 2 kg and initial velocity is 2I minus 3j. Final velocity is this. We have to find change in momentum. What is change in momentum? Mass into final velocity minus initial velocity. You say change in momentum in this case will be, what is the value of mass over here? That is 2. What is final velocity? That is 5I plus 2j. Okay. Then minus initial velocity. That is 2I minus 3j. Something like this. Now we can write it like this. This is 2. Then you say 5I cap plus 2j cap. This is minus 2I cap. Minus into minus is plus 3j cap. Now further we can write change in momentum will be 5 minus 2 is 3I cap. So this is 2 into 3I cap. Then 2 plus 3 is 5j cap. Now change in momentum in this case will be 2 into 3 is 6I cap plus 2 into 5 is 10j cap. This is change in momentum. Even you can find its magnitude also. Even you can find its magnitude also. Okay. Yes. Okay. Now guys, take a look. Take a look. If object, see. There are four cases we discuss in change in momentum. This is case one. This is case one. See guys, this is the wall. An object is moving with certain velocity. You are throwing an object and finally it comes to rest. It is like you are taking the mud. You are throwing it on the wall. This is the initial velocity. This is the final velocity. What is going to be the change in momentum in this case? Take a look. Take a look. Change in momentum will be mass into final velocity minus initial velocity. Sir, mass is m. Final velocity is 0. And what is the initial velocity? Guys, this velocity is in the left direction. If velocity is in the left direction, we consider it negative. So minus v. If it is towards right, we consider it positive. Minus into minus is plus. So it is going to be m into v. So this will be change in momentum in this case. Okay. Case 2. Let's suppose, my dear friends, this is the wall over here. Okay. Now, if you are throwing an object with certain velocity, it is reflected back with the same velocity. What is going to be the change in momentum in this case? See guys, you say mass into final velocity minus initial velocity. So here mass is mass into. What is final velocity? That is v. Minus. Initial velocity is minus v. Why? Because it is towards left. So it is minus v. So this will be mass into v plus v is 2v. So that is going to be 2mv. 2mv. Okay. Yes. Now, my dear NEET aspirants, case 3. Case 3. Listen to me very carefully. This is the object. This is the initial velocity. Okay. And this is the final velocity. Take a look. What is going to be the change in momentum in this particular case? See guys. You say, sir, mass into final velocity minus initial velocity. I'll be showing you all the cases, whatever the cases you have. So we say change in momentum in this case will be mass into final velocity. Guys, this is the final velocity. Is it along x direction or y direction? Sir, y direction. So this will be v and then you mention j cap. Sir, this velocity, is it along x direction or y direction? X. This is minus v I cap. If the vector is along y, mention j, consider j cap. If the vector is along x, consider I cap. Okay. Now guys, we can write it like this. Delta P in this particular case, this is going to be mv j cap minus, we say, mv I cap. Even you can draw this also. Draw this in the vector form also. mv j cap. Oh, sir, this is mv j cap. Means in the y direction, this is the momentum. Minus mv I cap. Minus mv I cap will be this. So this is minus because this is plus mv I cap will be in the right, minus mv will be in the left direction. Now, if you have two similar vectors, my dear NEET aspirant, their resultant is always, okay, that is a root 2 of mv, Sir, we are confused with this. Okay, let me tell you. So this is basically this one. In this particular case, you can find the magnitude also. That is going to be under root of, you can say, coefficient of j, coefficient of I. That is going to be mv whole square plus, you say, mv whole square. If you want to find the magnitude over here, that is under root of this square plus this square. So can I not say this is going to be under root of 2 times, this is 1 plus 1 is 2 times mv, I would say, whole square. Square root will cancel. So this is going to be a root 2 of mv. Oh, sir, crystal clear. How many of you understood this? Please tell me in the chats. A root 2 of mv. Tell me, guys, quickly in the chats, how many of you understood this? How many of you understood this? Tell me quickly. Okay. Then you have case 4. Then you have case 4. Take a look. Take a look. See guys, this is case 4. Let's suppose this is the surface. You're throwing an object something like this with a velocity v. Now if this is velocity v at an angle theta with the vertical, this is going to be v cos theta, this is going to be v sin theta. Okay. Now when it strikes with the same velocity v, now guys, here it is making theta with the vertical. Okay. Here also it is making theta with the vertical. Like if this is theta, this will be theta. If this is theta, this is theta. If this is theta, this is theta. Simple, bro. If this is velocity v, this will be v cos theta, this is v sin theta. If this is velocity v, this is v cos theta and this is v sin theta. Okay, cool. Sir, what is initial velocity? Initial velocity is v sin theta I cap, because this is in the x direction. We say then minus v cos theta j cap. Why minus? Because it is downward. Oh, ladies and gentlemen, this is plus I, this is minus I. This is plus j, this is minus j. So here velocity is downward. That's why I'm saying minus j cap. How do you write this velocity? This velocity final. This is v sine of theta I cap, then plus v cos of theta j cap. Oh, amazing. Now, my dear NEET aspirants, if I say what is going to be the change in momentum in this particular case, what is going to be the change in momentum? Change in momentum. What will you say? You say, sir, that is going to be mass into final velocity minus initial velocity. You say, sir, that is going to be mass into, what is the value of final velocity? This one. This is the value of final velocity. I'll write it like this. That is v sin theta I cap plus v cos theta j cap. Okay. Then you say minus. Initial velocity is this. That is v sin theta I cap minus v cos theta j cap. Okay. Then, my dear NEET aspirants, take a look. Take a look. You see over here, this is mass. You say this is v sin theta I cap plus v cos theta j cap. Then you said this minus v sin theta I cap, minus into minus is plus v cos of theta j cap. You can write it like this. Now, don't you think in this particular case, we can cancel this and this? This is negative, this is positive. So what is going to be v cos theta plus v cos theta? That is 2v cos theta j cap. So it is going to be 2 this m v cos of theta j cap. This will be the change in momentum. Now I'll tell you a trick. Over here. See. Guys. V cos theta, v sin theta. Could you please tell me due to which component of velocity the object strikes with the surface? V cos theta, obviously, because v cos theta is towards the surface. It strikes with the surface. So this only will change the momentum. Here, v cos theta, or I would say here, cos component of velocity changes the momentum. So because due to this only it strikes with the surface. So we say due to this cos component only it strikes with the surface, and that is the reason we got 2mv cos theta. Now using the same logic, ladies and gentlemen, if let's suppose this is the case 5, this is velocity v, this is angle theta, this will be v cos theta, this will be v sin theta. So it is reflected with v, this is v sin theta, this is v cos theta. Tell me, v cos is parallel to this. Here, due to v sin theta, it is striking the surface. Due to v sin theta, it is coming back from the surface. Don't you think, ladies and gentlemen, here, change in momentum must be due to this sine component? Yes. See, change in momentum is 2mv sine theta I cap. Complete derivation. I hope this is crystalline clear. I hope this is crystalline clear. So simple. If this is due to this cos, it is striking the surface, change in momentum will be 2mv cos theta. If sine is striking the surface, change in momentum will be 2mv sine theta I cap. Please tell me in the chat if this is clear. So tell me, oh. Tell me, I need the signal from every single student who sir is watching. Now guys, Newton's second law of motion. Newton's second law of motion. Take a look. See guys, let's suppose there is an object over here. It is moving with the velocity v, its mass is m. Could you please tell me what is the momentum here? P is equal to m mass into velocity. Okay. Now you are applying some sort of force. You are pushing this object. What is going to happen with this push? Its velocity will change. So after some time, its velocity is v dash. Now guys, due to this force only, velocity is changed. Now what is the momentum over here? Mass into v dash velocity. Momentum is changed. I would say due to the external force, velocity changes. So momentum changes. Okay. So momentum changes. So my dear NEET aspirants, here if momentum is changed, is it because of the external force? Yes. So we can say this external force, due to this external force, I would say momentum is changed. How do we write change in momentum? We say delta P divided by delta T. So this is what we call the Newton's second law of motion. What does Newton's second law of motion say? If there is an object, it is moving with certain velocity, it has some momentum. If you apply certain force, if you apply some force, it will change the momentum. It will change the velocity, so momentum will change. So that is a rate of change of momentum with respect to time is directly proportional to the force. As simple as that. Okay. Now guys, don't you think that previously I have told you, sir, when it comes to the average velocity, you have told us delta S by delta T. And when it comes to the instantaneous velocity, that was ds by dt. Yes, sir, something like this. So same is the case over here. This is also what we call the average force. So if you are applying force from this point to this point on the object, due to that average force from this point to this point, there will be total change in momentum from this point to this point. So due to this average force, there is total change in momentum. Change in momentum. So due to this average force, there is total change in momentum from this point A to, I would say, this point B. From point A to point B. Now if I say, can I write the instantaneous force over here? Also, I would say F instantaneous will be, that is dp divided by dt. Due to the instantaneous force, there will be the change in momentum at a particular instant. How much will be the, let's suppose if you are applying the force at this instant, so momentum will change at this instant. Okay, so due to the instantaneous force, momentum changes at a particular instant only. Momentum changes at a particular instant only. Yes, sir. Absolutely, sir. Now, my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. We say since we say momentum is mass into velocity. Now take this equation. Can I not say this external force is equal to d divided by dt of, what is momentum instead of momentum? I would say mass into velocity. Is this dp by dt? So I would say d of mv, d by dt of m into v. Yes. Now guys, listen carefully. Listen carefully. It is differentiation of mass and velocity. It is differentiation of mass and velocity. Like it is differentiation of uv. How do you differentiate over here? Guys, can I not say this external force will come out to be? How do you differentiate? Product rule. We say keep m as it is, differentiation of velocity with respect to time. Then plus. First you keep this as it is, then differentiation of this v. Then keep v as it is, then differentiation of mass, dm divided by dt. So we can write this force something like this also. Yes, sir. Now, my dear NEET aspirants, let's suppose if I say, if we say mass of an object is constant. If mass of an object is constant, then dm by dt will come out to be 0. Why, sir? Because dm by dt means change in mass. If mass is constant, mass will not change, so dm by dt will be 0. So in that case, what is going to be the external force? That is going to be m. That is dv divided by dt, because this term will become 0. dv by dt will be acceleration. So in that case, external force is going to be mass into acceleration. So this is the Newton's second law. Then mass of an object is constant. And mass of an object is constant. Now guys, we say if velocity is constant and mass is variable, in that case, what is going to be the force acting on the object? That is m. Guys, if velocity is constant, so can I not say then dv divided by dt will be 0? Change in velocity will be 0. So in that case, force is going to be, guys, this term will become 0 and this term will be over here v, that is dm divided by dt. This will be the force in that case. So if both are variable, then you can use this force. Tell me in the chats, quickly in the chats, if this is crystal and clear. Everybody out there, come on guys. I need the signal in the chats if everything is crystal and clear. Yes, there will be the break. Wait. I'll give you the break. Now, guys, take a look. Take a look at this question. So basically, when it comes to the Newton's second law, listen to me very carefully. We say first we studied that is delta P divided by delta T. This is what we call the average force. Then we say instantaneous force. So that is dP divided by dt. Okay? Yes. Rate of change in momentum with respect to time at a particular instant will give you the instantaneous force. Okay? Then you studied F is equal to V dm by dt plus m dv by dt. So this is the force when both velocity is variable as well as mass is variable. And my dear friends, if mass is constant, in that case, F is equal to ma. If velocity only is variable, if velocity is constant and mass is variable, in that case, F is equal to V dm by dt. Oh. Crystal clear, sir. Crystal clear. Take a look. A force of F is equal to 6i cap minus 8j cap plus 10k cap produces an acceleration of this. So force is acting on a body. It is given as 6i cap minus 8j cap plus 10k cap. Okay. This is the force. And acceleration is given as root 2 meter per second square. You guys are supposed to tell me what is the mass. Could you please tell me? Tell me, guys, in the chats, what is the mass? What is the mass? Tell me. So this is the force. Could you please tell me what is the magnitude of force? That is under root of 6 square plus 8 square plus 10 square. Okay. 36, 64, 100. So this will come out to be root 200. Now, guys, we say force is equal to mass into acceleration. So can I not say this mass will be force divided by acceleration? What is the value of force? That is root 200. What is the value of acceleration? That is root 2. So this is going to be root of 200 divided by 2. 2 ones are 2 hundreds are. So mass will come out to be root 100. That is 10 kgs. That is 10 kgs. Mass of the object is 10 kg. Take a look. A player catches a cricket ball of 200 grams moving with a speed of 20 meter per second. See, guys, there is a player. It catches a cricket ball. There's a ball which is falling in my hands, okay, with a velocity speed of 20 meter per second. If the time taken to complete the catch, is 0.5 seconds, the force exerted on the player's hand is, guys, let's suppose if I catch the ball, we say this ball is going to apply the force on my hand, we have to calculate that force. See. We say force is simply that is change in momentum, delta P divided by delta T. How do we find the change in momentum? That is simply. That is final momentum minus initial momentum. That is mass into final velocity minus initial velocity. See, guys, if I catch the ball, initially the velocity of the ball is 20 meter per second. Finally, ball comes to rest. Final velocity is 0. So mass of the ball is 200 grams. So it is going to be 200 divided by 1000 because we are converting it into kgs. And initial final velocity is 0 minus initial velocity is 20. So it will come out to be this minus is out. So this is 0, 0, 0, 0, 0, 0. 2 into 2 is 4. It is minus 4. Change in momentum. If I say what is the magnitude of change in momentum? That is 4. That is 4. Okay. Now here, this force will come out to be change in momentum is 4. And how much time it is taking? 5 seconds, 0.5 seconds. So 0.5 means 5 divided by 10. 0.5 means 5 divided by 10. 4 in 10 is 40. 40 by 5 is 8. So it will come out to be 8 newtons. Oh, is this clear? Oh, is this clear? JE 2022. JE 2022. A balloon of 10 kg in air. Okay, okay. This question you need to do once we study the rocket propulsion. After the rocket propulsion. After the rocket propulsion only. Here. Okay. Let's come on to this one. Now you have slope of momentum versus time graph. See, guys. Let's suppose you have momentum versus time graph. This is given. Let's suppose if I ask you what is the slope over here. Slope is always tan theta. Tan theta means perpendicular by base. What is perpendicular over here? That is P, or we say delta P. What is base? That is delta T. Okay. Slope is delta P divided by delta T, or P by T, or dP by dt. Now guys, we recently studied this force is equal to delta P divided by delta T. This delta P by delta T is actually force. And from this, we can say slope means, how do we find slope? That is this perpendicular, this will be base, delta P by delta T. Now this is equation first, this is equation second. I would say from first and second, can I not say this force will be equals to the slope? In case of momentum versus time graph, PT graph. So guys, take a look. So this is momentum versus time. If somebody asks you to find the force in case of momentum versus time graph, you find what? You find what? You find slope. You find slope. Take a look at this. Area under force time graph. Let's suppose you have force versus time, you have to find the area. I have told you so many times, when you have to find the area under the curve, you say integration of whatever is on y-axis, that is force, and whatever is on x-axis, that is dt. Like. If this is y versus x graph, if I say what is this area, how much is the area under this graph, this area, you say area is simply integration of whatever is on y-axis, and then we say multiply with dx. Okay. Now guys, tell me one thing. We say, since, call this equation first. Since we say this force is equal to dP divided by dt. This is what we have studied recently. Now take this over here. We say this dP is going to be F dt. Yes. Now integrate both sides. If you integrate from this side, if you integrate from this side. Integration of dP, small change in momentum. It is going to give you large change in momentum. And this will be integration of F dt. Call this equation second. Now take a look at equation first and equation second. See guys, can I not say from equation first and equation second? First and second. See, left hand side equal. So what I can say, this change in momentum is going to give you the area. Area is going to give you the change in momentum. So in which graph? I would say in case of force time graph. So my dear NEET aspirants, from now onwards, if somebody asks you what will be the change in momentum from force versus time graph, you'll find what? You'll find area. Okay. 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 Is that clear? Is that clear? Now guys, take a look. Impulse, impulse. Impulse simply means short time force. Impulse simply means, yes, I'll give you the break, wait. Impulse simply means the short time force or change in momentum. See guys. Let's suppose this is my hand. I am with this right hand. With my right hand, I am applying the force on left hand for a longer time. Cool. Now guys, if I apply the force on my left hand, but for a very shorter time, this force is what we call impulse. Okay. We say he's impulsive. You can understand it like that. So this is impulse. Okay. Slapping somebody, you are giving impulse. You are creating impulse. And guys, how do we define it? We say this force is equal to dp divided by dt. Now take it over there. So this dp is going to be f dt. Okay. Now what is this f dt? This is force acting for a short time. Hey, what is dt is what? Small time. Delta t is large time. So now if you integrate from both sides, so this is going to be delta p, it will be integration of f dt. So this is integration of f dt means force is acting for a very small time. This is what we call impulse. So impulse is simply what? Change in momentum or force acting for a short time, for a very short time. So means from here also we can say force versus time graph. This also gives you change in momentum, or you say it gives you impulse. Oh, yes, sir. So either you say change in momentum, either you say area, or you say impulse. As simple as simple. Is this clear? Yes, slapping somebody, tell him it is impulse. That's it. Okay. Let's suppose you have a question over here. A ball of mass 1 kg is moving horizontally with a speed of 10 meter per second. There is a ball, its mass is 1 kg, is moving horizontally with speed 10 meter per second. After striking with the vertical wall, when it strikes with the vertical wall, it returns with a speed of 5 meter per second. It returns with 5. Find impulse. Guys, when I say impulse, it is simply change in momentum. And that is going to be mass into final velocity minus initial velocity. So this impulse is equal to, what is the value of mass? That is 1 kg over here. What is final velocity? That is minus 5. That is minus 5 because it is going in the left direction. What is initial velocity? That is, this is minus initial velocity is 10. So impulse in this case will be minus 15. And if I say mod of I, that is going to be 15. Change in momentum means simply impulse. Okay. Take a look at this question. From the given force versus time graph, find the impulse from 0 to 8 seconds. Guys, from force time graph, you have to find impulse. So we say in case of force time graph, don't you think impulse means change in momentum, and change in momentum means area? When force versus time graph is given, you are supposed to find area. That means change in momentum, or that means impulse. Now tell me, how much is the area over here? Guys, so from 0 to 8 seconds, that means area of this plus area of this plus, I would say, area of this. What is the area of triangle? 1 by 2 base. Base is 2, altitude is 6. That is 2 and then 6 plus. Guys, I have told you so many times, upper area we take positive, lower area we take negative. So I would write over here minus. Instead of positive, I would write minus. And 4 minus 2, this length is 2. Length into breadth is 4. So this is 2 into 4. This area. And then this area, this is 8 minus 4 is 4 plus. Okay. And then this breadth is 3. 4 into 3. So when I say this area, this and this will cancel. So 6 minus 8 plus 4 into 3 is 12. Yes or no? So this area will come out to be 10, and that is impulse. That is impulse. Let's suppose you have this question. If the force F is equal to 500 minus 100t acts on a body, then impulse will be, guys, force is given. We say impulse is simply integration of F dt. I am showing you all the pattern of questions. Graph questions also. Now guys, impulse is integration of F dt. So this impulse will be integration of, what is the value of force over here? That is 500 minus 100t. 500 minus 100t, and then you say dt. Now guys, this impulse is going to be, now guys, what is the means short time force is impulse, integration of force with respect to time. What is the integration of 500? It is going to be 500t minus, what is going to be the integration of 100t? It will be 100t square by 2, because power plus 1 upon power plus 1. So this will be I is equal to 500t minus, this will be 50t square. Done and dusted, done and dusted. Yes, take a look at this. Oh, tell me in the chats, is this clear? Is this clear? Everybody out there, is this clear? Find the ratio of force acting on A and B. Okay. Momentum versus time graph is given. Momentum versus time graph is given. Okay. So you are supposed to find the force. Guys, when momentum versus time graph is given, I have told you, momentum versus time graph. In case of momentum versus time graph, you are supposed to find force. What will you find? Slope. You will find slope. You will find slope. So you have to find force FA divided by FB. So momentum time, there are two graphs which are given, A and B. Now guys, if this is 30, this angle will be how much? 60, because 60 plus 30 is 90. Now force on A, there is a body A, force on B, that is going to be slope of A divided by, I would say, slope of B. Now tell me, what is the slope of A? That is tan of 30. Slope of B, how much angle B is creating? That is going to be tan of 60. Tan 30 is 1 by root 3. Tan 60 is root 3. Root 3 into root 3 is 3. So answer is 1 divided by 3. Answer is 1 divided by 3. Tell me guys, is this clear? Is this clear? Take a look at this. A force F is equal to 2t I cap plus 3t square j cap Newton acts on an object moving in xy plane, then find the magnitude of change in momentum in time t. Guys. Force is given. You are supposed to find the change in momentum. We say, guys, how do we say force is equal to change in momentum upon change in time? Or you say like this, F is equal to dp divided by dt. Now take it over here. So dp is going to be f dt. Now integrate both sides. So this will give you delta p, change in momentum, is equal to integration of f dt. So means if you want to find the change in momentum and force is given, you are supposed to integrate. So I would say change in momentum is going to be integration of, what is force? That is 2t I cap plus 3t square j cap. Then you say dt. And it says you have to find the change in momentum from 0 to 2 seconds. So put it over here 0 and over here 2. So delta p in this case will be. Now guys, what is the differentiation of 2? So it is 2. That is, what is the differentiation of t? That is t square divided by 2. And you mention this I cap. Then plus, what is the differentiation of 3t square? That is dt cube divided by 3. Power plus 1 upon power plus 1, and this is j cap. And limit is from 0 to 2. Now 2 and 2 will cancel, 3 and 3 will cancel. So delta P will come out to be. So here it is T square I cap plus T cube j cap, 0 to 2. Now guys, you put the upper limit in this T, then you put lower limit. So delta P in this case will be, put the upper limit, that is 2 square plus, because lower limit will be minus 0, that is 2 square only. Okay. Is it lagging? Guys, is there a lag? Okay. Now put the upper limit over here, then minus lower limit, plus put the upper limit over here, that is 2 cube. Then delta P in this case will be 4 plus 2 cube is 8. This will be 12. Change in momentum is 12. JEE 2024 question. The impulse is large in the figure. Guys. What is given over here? Force versus time, force time, force time, force time. We say, in case of force time graph, impulse means area. Okay. Now, if I say, in which of the 4 graphs area is large? Second one. So in the second, you see area of this is large. You say area is large in second. So impulse is large. As simple as that. As simple as that. Okay. Yes. No, it is not necessary to read NCERT physics line by line, but what I would recommend is to solve all the questions which are mentioned, which are present in the NCERT. Read the previous year questions, okay? Or you have exercise, you have solved examples, whatever it is, solve all the questions. Okay. Now guys, conservation of momentum. Conservation of momentum. Conservation of momentum. Take a look. What does conservation of momentum actually mean? If net external force acting on a body system is 0, then momentum of the system remains conserved. See guys. If I say, let's suppose this is a ball over here, its mass is m, velocity is v. This is a system. Okay, this is a system. If I say no net external forces acting on this mass, so what is going to be the velocity of this body over here? That is v. What is momentum over here? M into v. What is momentum over here? M into v. Can I not say momentum is same? Yes, momentum is same when external force net is equal to 0. No net external forces acting. Then only. Now guys, let me prove it like this. Let's suppose we say as force is equal to dp divided by dt. This is net external force is equal to dp by dt. If let's suppose what does this equation say? It says that if you apply the force on any body, if you apply the force on any body, net external force, then in that case, momentum of that body will be changed. Okay. Okay. Yes. Now, my dear NEET aspirants, see, see, see. When I say in this particular case, this dp, it is going to be f dt. Okay. Yes. If, or you directly write, if we say f net external force on the system is 0, then this will be 0 is equal to dp divided by dt. Yes. Now multiply it over here, dp will come out to be equal to 0. And you multiply this with this one, dp will come out to be 0. What is this? dp means change in momentum. Change in momentum is 0. That means initial momentum will be equals to the final. That means initial momentum will be equals to the final momentum. So if net external force acting on a system, on an object is 0, in that case, whatever is the initial momentum of the object will be equal to the final momentum. Yes. Sir, famous example of this is gun bullet system. Gun bullet system. Gun bullet system is the example of conservation of momentum. Now, guys, if you take a look over here, there is a gun and there is a bullet. When you fire a gunshot, is there anybody from the outside which is applying the force on the gun? Like I'm firing the gunshot, it is like I'm pushing the gun, then the bullet comes out. No, it does not like. It is not that way. Okay. So, my dear friends, what happens is we say it is the force inside which is acting on this bullet. Due to that force, we say gun is applying the force on the bullet from the inner side. Due to that only this bullet comes out of this gun. It is not like somebody from the outer side applies the force on this bullet, on this gun. Okay. So basically when I fire the gunshot, it is something happens from the inner side and then the bullet comes out. Those are the internal forces. We say here, net external force. Here, I would write over here, net external force on the gun bullet system is 0. So whatever is the initial momentum, same is going to be the final momentum after firing the gunshot. Momentum remains conserved. Now, if I say what is the initial momentum of this gun bullet system, that is 0. Why? Because gun is at rest, bullet is at rest. Okay. Then, my dear friends, after firing the gunshot, this is initially, and this is finally. After firing the gunshot, so basically this bullet moves in the forward direction when you fire the gunshot. So gun is basically pushed in the backward direction. This is what we call recoil of the gun. And bullet goes forward, gun comes backward. Why is it like that? Because in order to conserve the momentum. See guys, so when finally gunshot is fired, bullet moves forward, gun moves backward. Now what is the initial momentum? 0. Net external force is 0 and initial momentum is 0. What must be the final momentum? Final momentum must be 0. Final momentum means momentum of the gun plus momentum of bullet, because this itself is a system. What is the momentum of the gun? Guys, that is mass into velocity of gun. Mass of gun is m, velocity of gun is vg, and I would say minus. Why? Because it is backward, gun moves backward, and then plus. What is the velocity of this? That is m, and this is velocity of bullet. This is what we call the final momentum. Guys. What is the initial momentum of gun plus bullet? 0. Finally, momentum of gun plus bullet must be equal to 0. So this will be 0 is equal to minus mv of g plus mv of b. Now guys, this will go over here. See, mass into velocity of bullet will be equals to, or you can write it like this. Take it over here. Mass into velocity of gun will be equals to mass into velocity of bullet. See guys. Listen. I'll give you the crystal clear feel. When bullet moves forward, its velocity is large and its mass is less. When gun moves backward, its velocity is less, mass is more. See, here mass is more, velocity is less. Here velocity is more, mass is less, and their combination product will be same. So this will cancel with this. Momentum of gun will be cancelled with the momentum of bullet. So final momentum will be zero as initial momentum is. This is the crystal clear proof. Guys, is this clear? Is this clear? So basically, when we fire the gunshot, before firing the gunshot, we say momentum of gun plus bullet is zero. That is initial momentum. After firing the gunshot, gun is being pushed backward and bullet moves forward. Whatever is the momentum of the bullet in the forward direction, same is the momentum of the gun in the backward direction. So net is finally also zero. So from here, we can say velocity of this gun. This is recoil velocity. This is what we call recoil velocity. Velocity of the gun will be equals to mass into velocity of bullet divided by mass of this gun. This is what we call the recoil velocity of the gun. This is called the recoil velocity of the gun. This is called recoil velocity of the gun. Hey, tell me in the chats, is this clear? Tell me in the chats, is this clear? Tell me guys quickly. Now guys, take a look. We say, see. As we say, when it comes to the kinetic energy, listen to me very carefully. We say kinetic energy is 1 by 2 mv square. This is the formula of kinetic energy. We say multiply with mass and divide with mass. So this kinetic energy will come out to be mass into mass is m square v square divided by m into 2 is 2m. Now take it over here. So this will be 2m into kinetic energy. It will be equals to m square v square. Now take the square over here. So mv will come out to be under root of 2m into kinetic energy. Now what is this m into v? This is momentum. So momentum is under root of 2m and this is ke. Okay. Or from this equation only, you can write it like this. So kinetic energy will be equals to m square v square, that is p square, momentum square divided by 2. Now guys, tell me one thing. In case of gun bullet system, don't you think that this momentum is conserved? Momentum remains the same. So if this is constant, so can I not say kinetic energy is inversely proportional to mass? Yes. The one which has less mass will be having the more kinetic energy. Now tell me, since we say mass of bullet is less than mass of gun, so can I not say kinetic energy of bullet is greater than kinetic energy of gun? Absolutely, sir. Absolutely, sir. Momentum is conserved. We say in that particular case, we say kinetic energy of bullet will be greater as compared to the kinetic energy of gun. Okay. Yes. Now, we say if gun fires n bullets per second, every second the gun is firing n bullets with velocity v and mass m, then force on the gun will be, guys, listen carefully. Listen carefully. We say force on the gun. Force on the gun. Okay. How do we calculate? See. When you are applying, when you are basically firing the gunshots, we say in that particular case, we say this gun is being pushed back. So means force is applying on the gun, force is acting on the gun. So I would say on firing the gunshots, we say force acts on the gun. I would write on firing the gunshots, we say force acts on the gun. Now guys, see, how do we calculate that force on the gun? You say, sir, that is change in momentum upon change in time. And it says every second means in 1 second. Guys, see, this force on the gun will be, sir, what is change in momentum? Change in momentum is going to be, guys, when you fire the gunshot, initially gun was at rest, finally gun has velocity v. So I would say that is going to be m into velocity v. M into velocity v. If gun fires n bullets per second with a velocity v and mass m, then force on the gun will be, and guys, whatever is the force on the bullet, same will be the force on the gun. And that is delta P by delta V. Now, my dear friends, we say this force on the gun will be, guys. So here in this particular case, momentum is conserved. We say in this particular case, we say whatever is the force on the gun, same will be the force on the bullet in that particular case. Now see, we say delta P. Delta P means change in momentum. Before firing the gunshot, what is the initial momentum? 0. After firing the gunshot, what is the momentum? M into V. So that is mass into final velocity minus initial velocity divided by time is 1 second. Every second it is asking. So force on the gun will come out to be mass into final velocity is V, initial velocity is 0 divided by 1. So force on the gun will come out to be M into V. So this is force due to 1 bullet. If I say force due to n bullets, force due to firing n bullets, so that is going to be n m v. Please tell me in the chats if this is crystalline clear, or you directly remember it, my dear friends. If you are firing n bullets with a velocity v, okay, then in that particular case, force on the gun is going to be n m v. Is this clear? Tell me in the chats, everybody out there. Tell me. A bullet of mass 40 grams is fired. A bullet of mass 40 grams is fired from a gun of 10 kg. From a gun of 10 kg. If the velocity of the bullet is 400 meters per second, the recoil velocity of the gun will be, guys, recoil velocity of the gun it is asking. This is the recoil velocity of the gun. Mass of the bullet, velocity of the bullet divided by mass of the gun. As simple as that. As simple as that. So we say recoil velocity of gun is mass of the bullet, velocity of the bullet divided by mass of the gun. Now, what does the question say? A bullet is of mass 40 grams, 40 grams. So this is 40 divided by 1000. Okay. Then velocity of the gun, velocity of the bullet, velocity of the bullet is 400 meter per second divided by mass of the gun, mass of the gun, mass of the gun is 10 kgs. Okay. 0, 0, 0, 0, 0, 0. 4 into 4 is 16 divided by 10. Oh, yes or no? 1.6 meter per second. This is velocity of the gun. See, a machine gun fires a bullet of mass 65 grams with a velocity of 1300 meter per second. Okay. A machine gun fires a bullet of mass 65 grams. Okay. Mass is given as 65 grams with a velocity of 1300 meter per second. So bullet is fired with a velocity of 1300 meter per second, 65 grams. The man holding it exerts a maximum force of, so force acting on the man is 169 Newton. Guys. When you fire a gunshot, let's suppose you're basically firing the gunshots with a machine gun, something like this. So what happens over here is, while you fire the gunshot, so this gun is going to apply the force on the person. So basically force applies on the gun. That gun applies the force on you. And how much is that force? 169 Newton. Okay. The man holding it exerts a maximum force of 169 Newton on the gun. Okay. The number of bullets fired will be, we are supposed to find the value of N. Okay. So means, my dear friends, we say force in this case will be NMV. As simple as that. NMV. Oh, yes or no? Force, this is the force acting on the gun due to the firing of N number of bullets. And this in this particular case is 169. This is N. Mass of the bullet is 65 divided by 1000 into velocity is 1300. Oh, yes or no? Is this clear? Is this clear? Check the value of this. 0, 0, 0, 0. I guess N comes out to be equal to 2. Please check it from your end. Please check it from your end. Now comes the rocket propulsion. Now comes the rocket propulsion. Now comes the rocket propulsion. See, guys, what does rocket propulsion actually mean? Rocket propulsion means while you are launching the rocket, when the rocket goes up. Okay, let's suppose you are supposed to send the rocket on the moon. So we launch the rocket from the earth. So that is what we call the rocket propulsion. This is the rocket over here. This is the fuel inside the rocket. Okay. So basically when fuel burns, it comes out in the form of exhaust gases. It comes out in the form of exhaust gases. See, here, how does rocket propulsion take place? How does rocket go up? Let's understand that. Here, fuel of the rocket burns, due to which, when fuel inside the rocket burns, we say due to which exhaust gases come out of the rocket. Due to which exhaust gases come out of the rocket. Okay, smoke, other gases. Okay. We say rocket pushes the gas down. We say rocket pushes the gas down. So this gas comes out of the rocket. It pushes the gas down. And gas pushes the rocket up. In return, while basically rocket pushes the gas outwards. So this gas in return pushes the rocket up. Due to which upthrust force is created on the rocket. Due to which upthrust force is created on the rocket and rocket is being pushed upwards. Okay. And my dear friends, we say here mass of the rocket is decreasing. Why? See guys, as the rocket goes up, we say fuel burns. It comes out in the form of exhaust gases. Fuel burns in large amount, by large amount, like 6 kg per second, 8 kg per second, 10 kg per second. Okay, every second 10 kg fuel burns. We say the mass of the rocket decreases. Mass of the rocket every second 10 kg decreasing. In 10 seconds 100 kg decreasing. Okay, so we say here mass of the rocket is decreasing while it goes up. Okay. Now, my dear friends, here it is mentioned mass burned in time t. In time t, how much mass is burned? How much mass is decreased? You say that is dm by dt into t. What is dm by dt? Whatever the things I tell you over here, please remember it directly. Okay. So we say dm divided by dt into t is the mass burned in time t. If I say, yeah, every second, guys, every second, I say 5 kg mass is decreasing, burning. Every second 5 kg fuel is burning. I am asking you how much mass is decreased in 3 seconds. You say 5, 5, 5. We say 15 kg. So that's what I'm saying. So every second 5 kg mass is burning. 5 into, in 3 seconds, 5 into 3 is, that is 15. So 15 kg mass is decreased. So dm by dt is the rate of fuel burning. With what rate fuel is burning? If I say fuel is burning at the rate of 10 kg per second, every second 10 kg it is burning. So in 10 seconds, how many kgs it will decrease? So 10 into 10, it is 100. Oh, I hope this is crystal and clear. Now, my dear friends, one more important thing. We say initial mass of the rocket we consider m0. Okay. Before burning, what is the mass of the rocket? That is m0. Now, remaining mass after time t, when mass is burned after time t, how much is the mass of the rocket? Guys, important. We say mass of the rocket after time t, it is initial mass minus burned mass. This is the initial mass. This is what? Burned mass. Yes or no? Mass burned in time t, that is dm by dt into t. So if I say what is the remaining mass, you say whatever was the initial mass, so whatever is the burned mass. So initial mass, if I say initially it was 100 kgs, burned is 5 kg, 100 minus 5, that is 95 is remaining. Okay. And my dear friends, velocity of the exhaust gas, basically when the rocket goes up, so this gas comes out with a velocity v. This is the velocity of the exhaust gas. Velocity of the exhaust gas is v. And rate of change of mass is dm by dt. Now, my dear NEET aspirants, we say, if somebody says, how much will be the upthrust created over here? So we say upthrust in this particular case is going to be v dm by dt, where v is the velocity of the exhaust gas, dm by dt is the rate with which the mass is decreasing. Sir, amazing equation. This is going to help in solving a lot of questions. Yes. Now, one more important point we discuss over here. See, we say acceleration of the rocket at t is equal to 0 initially. At t is equal to 0, when the rocket is launched, what is the acceleration? Okay. When the rocket is about to go up, in that case, guys, please, acceleration will be net force divided by mass. In that case, initially acceleration will be, what is the net force? Sir, that is upthrust. Upthrust is v dm by dt. So this is the force acting on this. Okay, upthrust, you say v dm by dt. This is the upthrust net force divided by net mass. Initial mass is m0. Sir, I am able to understand each and every single thing over here. This is when gravity free space. If I say gravity is present, my dear NEET aspirants, if I say gravity is present, in that particular case, you say acceleration is going to be v dm by dt upthrust minus we say g, divided by, we say m0, Okay. So this is when gravity is present. If gravity is not present, then acceleration initially will be this. If gravity is present, then it will be this. Obviously, if gravity is present, in that case, net force will be taking Upward force minus downward force, that is mg. Upward is v dm by dt, downward is mg. Okay? Yes. Now guys, one more important thing. We say acceleration of the rocket after time t. So after time t, what is going to be the acceleration of the rocket? See. We say acceleration of the rocket after time t is v dm by dt. This is upthrust net force divided by net mass at that point of time. What is going to be the mass? But tell me, what is the mass of the rocket at time t? At time t, remaining mass m naught minus dm by dt into t. So that is what I am putting over here. Net force divided by net mass, m naught minus dm by dt into t. M naught minus dm. This is the remaining mass after time t. This is the upthrust at time t. When gravity is present, this is gravity free space. When gravity is present, in that case, we'll say v dm by dt, m naught minus dm by dt into t minus g. That's it. So tell me in the chats, how many of you understood this? Please, right now I need the signal from you guys. Tell me how many of you understood each and every single point in this case. Tell me. Great. Now, see. This question. Let's take a look at this question. A rocket of mass 5,700 kgs. There is a rocket, it has mass of 5,700 kgs. Okay. Ejects mass at a constant rate. Ejects mass means gas is coming out, fuel is burning, 15 kg per second. Every second 15 kg fuel is burning. Every second 15 kg mass is decreasing with a constant speed of, I would say, 12 kilometer per second. The acceleration of the rocket after 1 minute after the blast is, so basically after 1 minute the rocket is launched, what is going to be the acceleration? Guys, acceleration of the rocket after time t. So what I can write in this particular case, I would say acceleration of the rocket after time t. What is that? V dm divided by dt upon m naught minus dm by dt into t. I would say dm divided by dt into t. Okay, then minus, I would say g. Oh, sir, just one line question. If you know the concept, a rocket of mass 5,700 kgs. Okay, this is the initial mass of the rocket, that is m naught. Ejects mass at a constant rate. So this is the value of dm by dt. In this particular case, I would say dm by dt is given as 15 kg per second. At a constant speed is given as 12 kilometer per second. So that means 12,000 meters per second. Okay, and acceleration of the rocket after t is equal to 1 minute, time is given as 1 minute over here. That means 60 seconds, and here it is 12,000 meters per second. Okay, and what is the value of g? That is 10. Now you need to put all these values in this one. Value of v, that is given. Value of dm by dt, that is given. Value of m naught. What is the value of m naught? M naught is given as 5,700 kgs. So put it over here and solve the question, you'll get the answer. I hope this is crystal and clear. Like you have this, you have a 600 kg rocket is set for a vertical firing. A 600 kg rocket, this is a rocket, okay? 600 kg rocket is set for vertical firing, okay? If the exhaust speed is 1000, so basically when the gases come out, speed of the gas is 1000 meter per second. The mass of the gas ejected per second to supply the thrust needed to overcome the weight will be, guys, what is the force acting on this one? That is mg. So what is the force acting in the upward direction? That is upthrust. Because of upthrust only it will go up, and that is v dm divided by dt. Now guys, it says that the mass of the gas ejected per second, okay, it says that, see, how much mass we need to eject every second means we have to find the value of dm by dt. How much gas we need to eject every second so that this upthrust, upward force balances the downward force. If I say downward force is more, don't you think that rocket won't go up? Do you think that rocket is going to go up? No, because downward force is more. So this upthrust has to balance mg. How is that possible? That is only possible when it throws the gas out. Then the gas pushes it in the upward direction, which creates upthrust. So see the language of the question. The mass of the gas ejected per second. How much should be the mass ejected every second due to the gas to supply that upthrust, so that which supplies upthrust, which gives the upthrust to the rocket to overcome the weight, which basically balances this weight. We say here it says that this upthrust must be equal to mg. Then only this force must balance this force. How? When the gas comes out. So this is v dm divided by dt will be equals to m into g. Okay. Now guys, what is the velocity over here? That is given as 1000. Now dm by dt, that is what we are supposed to calculate. Dm divided by dt is equal to mass of this rocket, 600 kgs, into we say 10, 0, 0, 0, 0, 0, 0. So we say dm divided by dt will come out to be 6 kg per second. Oh, boys and girls, if every second 6 kg mass comes out, if every second we say 6 kg fuel is burning, if this rocket burns 6 kg fuel every second, then it will create an upthrust, sufficient upthrust, which balances this weight, that is mg. Tell me in the chats if this is crystalline clear. Tell me in the chats if this is crystalline clear. Tell me in the chats if this is crystalline clear. Everybody out there, quick. JEE 2022, another question on this one. We'll give you the break after this question. A balloon of mass 10 grams in air. There is a balloon. Okay. It has a mass of 10 grams in air. The air escapes from the balloon. So basically air is escaping from the balloon. Okay. At a uniform rate with velocity. So velocity of escape, velocity of exhaust gas, you can consider it. This is given as 4.5 centimeter per second. If the balloon shrinks in 5 seconds, this balloon completely shrinks in 5 seconds. Okay. Then the average force acting on the balloon will be, we are supposed to find what is going to be the average force acting on the balloon. See guys, see. In this particular case, we say when the gas comes out of the balloon, okay, exhaust gas comes out of the balloon, air comes out of the balloon. So when this gas is being pushed down, when air is being pushed down, due to that air, balloon is being pushed up with the upthrust. That upthrust will be equals to V dm divided by dt. We are supposed to find the value of this force. So this F will be, what is the value of V? That is 4.5. Now guys, dm, change in mass. So it says finally, guys, if the balloon shrinks means completely its mass becomes 0. So means what is the initial mass? That is 10. So dm means final mass minus initial mass. That is 10 minus 0 divided by. In time is 5 seconds. It is 5. Now it says 5 ones are 5 twos are 10. 2 into 4.5. So F will be equals to 9. It is not Newton, it is dyne. Why? Because we did not do the conversion over here. We kept it in centimeter per second only. Okay, so that's why whatever is the force over here, that will be in the dynes. This is another unit. Is this clear, boys and girls? Is this clear? So let's take a break, long break. Break till 9 p.m. So this is a 50 minutes break. See you guys at 9. Okay, guys, we are back finally. Let's move on to the Newton's third law of motion. Let's move on to the Newton's third law of motion. What does Newton's third law of motion say? Everybody know this? To every action, there is equal and opposite reaction. What does that mean? See, guys, it means if I have got a hand over here, if I'm pushing this hand with this hand, okay, so this hand is going to push it back. If I apply force on something, that something is going to apply force back on me. Like. This is a block placed on the table. Now, due to this block, we say normal force will act on the table, that is N dash. Okay. And due to this table, normal force on this block will act, that is N. This N and N dash are the action reaction pair. Okay. If block is applying the action, table is going to apply the reaction. Action reaction. Forces always exist in pairs, action and reaction. Okay. That's what we explained. How to identify action reaction pair? How can you identify action reaction pair? Guys, see. When it comes to the, see, this block, on this block, we say mg acts in the downward direction, n will act in the upward direction. And on the table, we say n dash will be the normal reaction. Sir, n dash and n, are these action reaction or n and mg are action reaction? That is, we need to figure out. See, action reaction acts on two different bodies. If I'm pushing the board is pushing me back. So action is on the board, reaction is on my hand. They must act on two different bodies. See, when it comes to mg is acting on the block, n is acting on the block. So they are acting on the same bodies. So n and mg cannot be action reaction. They must have the same magnitude. Magnitude wise, they also should be same. They must act simultaneously. They must be in the opposite direction. Okay. So we say these are the, we say triads of action reaction. So Newton's third law says to every action there is equal and opposite reaction. Okay. Now, my dear NEET aspirants, in this particular case, let's take a look at this motion of connected body system. If you have different masses connected, something like this, and somebody asks you to find the value of tension and acceleration, whenever you get a question something like this, always remember acceleration will be net pulling force by net mass. What is the net pulling force over here? Net pulling force will be considering over here this 20 divided by net mass, that is 6 plus 4, that is 10. Sir, shall I not consider this tension as a pulling force? No. These are the internal forces. So this is the net pulling force. This is the pulling force over here that we'll be considering. So this will come out to be 2 meters per second square. Then if you want to find the tension, take any body. Let's suppose I'm taking 4 kg. I would write over here FBD of 4 kg. If I'm taking 4 kg over here, we say in this direction tension is acting. This is 4 kg. And use Newton's second law. Use second law. What does second law say? Net force is equal to mass into acceleration. First, how are you supposed to find the acceleration? That is net pulling force upon net mass. Now, this is the acceleration of the entire system. This is the acceleration of this mass also, or acceleration of the entire system. So, this net force over here is tension. Mass in this case is 4. And acceleration came out to be 2. So, this came out to be 8 Newton. So, 8 Newton is the tension acting in this string. Okay. Let's talk about this one. Find tension T1, T2 and acceleration. How do you find the acceleration? We say net pulling force upon I would say net mass. Net pulling force upon net mass. Net pulling force in this particular case is 120 upon net mass, that is 7 plus 3 is 10, 10 plus 5 is 15. Okay, this is net mass. Okay, now 3 5s are 3 4s are. So 5 1s are 5 8s are. So this will come out to be 8 meter per second square. Okay. Now, if you are supposed to find the tension T1 or T2, let's find T1. Guys, consider FBD of I would say 7 kg block. Let's make the FBD of 7 kg block. So this is a 7 kg block. And in this direction, I would say T2 is acting. Use Newton's second law. Use Newton's second law. What does that say? Net force is equal to mass into acceleration. Net force is T2. Mass in this case is 7. Acceleration is 8. That is 56 Newton. Now, if you want to find the tension T1, you can consider this block also. You can consider this block also. Chalo, consider this block. We say FBD of I would say 3 kg. So this is 3 kg. In this direction, I would say 120 Newton is acting. In this direction, I would say T1 is acting. Now use second law. What does that say? Net force is equal to mass into acceleration. Net force means this force minus this force. 120 minus T1 is equal to mass into acceleration. Mass is 3. Acceleration in this case is 8. Okay. So this comes out to be. Take this over here, take this, that over here. So this is 120 minus, that is 24, will come out to be T1. Okay. So this T1 comes out to be 96 Newton. Is this clear? Please tell me in the chats, everybody out there. Guys, tell me. Is this clear? Everybody. Okay, that's great. Now, guys, let's move on to this question. See, in this particular case, we say, what is the force acting over here? That is 5G. What is the force acting on this one? That is 3G. And in this one, tension is T1, and in this one, tension is T2, because string is different. String is different. Now, first and the foremost thing, if I ask you what is the acceleration, that is net pulling force. Sir, shall I consider tension T1 and T2 as pulling force? No, no. Then what? This and this, 5G and 3G will be the pulling force in this case. 5G is greater, so you will be right, 5G minus 3G divided by, this is net pulling force divided by net mass. 5 plus 2 is 7, 7 plus 3 is 10, so this is 10 kg. So 5G minus 3G is 2G, 2G is 20. So acceleration will be 20 divided by 10, that is 2 meter per second square. Okay. Then if you want to calculate tension T1, we say consider, or I would say FBD of 5 kg. Let's make the FBD of 5 kg. This is 5 kg. In the downward direction, it is 5G. And in the upward direction, it is T1. Now, my dear NEET aspirants, clearly you can see 5G is greater than 3G. So block is going to come down. So acceleration will be something like this. Okay, this is going to be the acceleration. Okay. Now, my dear NEET aspirants, if I say net force, if I use Newton's second law, net force is equal to mass into acceleration. Net force will be 5G minus T1. 5G minus T1. is equal to mass into acceleration. Mass is 5, okay, and acceleration came out to be 2. 5 into 2 is 10. Now take it over there, take it over there. So this will be 50 minus 10. It will be equals to T1. So T1 will come out to be 40. T1 will come out to be 40. Let's find T2. We say FBD of 3 kg mass. So this is 3 kg mass. In the downward direction, I would say this is 3g. In the upward direction, it is T2. And acceleration is something like this. Now, my dear friends, if you use Newton's second law, you say upward force minus downward force because block is going up. So this force is greater than this. So T2 minus 3g is equal to mass into acceleration. That is 3 into A. So T2, this will go over here. So 3 into A. A is 2 minus this will be equals to 30. This will be plus. If it is, this will be plus 30. So this is 6. That is 36 newtons. Guys, tell me in the chats if this is clear. Tell me. Tell me. First, you find the net acceleration, net pulling force by net mass. Then find tension by considering the individual masses. Like this one. Question was asked in NEET 2020. Find the acceleration of the given system. See, guys, what is the force acting over here? 6g. What is the force acting over here? 4g. If I say acceleration, that is net pulling force. That is 6g minus 4g divided by net mass. 6 plus 4 is 10. So acceleration will be 2g divided by 10. So acceleration is going to be 2 meter per second square in this case. Now, if you want to find the tension, see, guys, if you want to find the tension, so I would say tension in this is T. Sure, also it is going to be T. Okay. Now consider any block you want to consider over here. So I am going to consider FBD of 6 kg. So this is 6 kg. In the downward direction, I would say this is 6g. In the upward direction, this is going to be tension and this is going to be acceleration. If you use the Newton's second law, that is net force is equal to mass into acceleration. So net force will be 6g minus this T is equal to mass into acceleration. Mass in this case is 6, acceleration is 2. So this is going to be 60 minus, this will be 6 2s are, that is 12, is equal to T. T will be 48 newtons. T will come out to be 48 newtons. This is the same question. Yes. Now comes the pseudo force. Lot of students actually have the confusion in the pseudo force, but I'm going to take that out today for once and all. See, what is this pseudo force all about? See, guys, imagine you are standing over here and you are standing at rest. You are here at rest. And there is a block over there at a large distance. You are looking at that block. According to you, can I say, according to me, that block will be at rest? Because if I am at rest, that block will be at rest. Now imagine you are inside a car. You're moving towards that block. It feels like that block is coming towards you. Or when you are inside the car, when you look outside the car, out of the window, it feels like trees are moving. But in reality, trees are at rest. It is you who is moving. So because of your effect, it feels like trees are moving. Yes, sir. Absolutely, sir. 100%, sir. Similarly, my dear friends, if there's a person over here which is at rest, if we place a block over here which is at rest, so according to that person A, we say according to A, block will be at rest. Now, if there is a person B which is moving with constant velocity, and there is a block over here, we say this person B will say, according to B, block is moving with a constant velocity. B will say it is moving with a constant velocity. but in reality, block is at rest. So it is B who is observing the block is in motion. Then if I say this person C is not moving with constant velocity, velocity is changing. When velocity changes, acceleration is there. So according to person C, we say block is accelerating, block has acceleration. Now you tell me one thing, is it truly accelerating, or this person C is basically experiencing this? So it is person C who is experiencing that block is in motion, block has acceleration. But in reality, block is at rest. So can I not say this acceleration over here is a pseudo acceleration, fake acceleration? Yes, fake or pseudo. Pseudo means fake. Why is it fake? Because this acceleration is only because of the person C. Okay, yes. Now, my dear NEET aspirants, when we say there is a block, if force acts on this block, we say it will have acceleration A. So this force will be mass into acceleration. So, my dear friends, we say whenever there is acceleration, there is force. Because without force, acceleration cannot be there. Without acceleration, we say whenever there is acceleration, there will be force, that is for sure. Now, if there is a fake acceleration of this block, we say this acceleration will be because of some force, and that force will be also the fake force, and that force is what we call the pseudo force. Oh. And this pseudo force will be equals to mass into acceleration. So means, sir, what you are trying to say is that in reality, this block is at rest. But when the observer who is observing the situation is moving with some acceleration, he feels that this has the acceleration. But in reality, this does not have the acceleration. That's why we call it this as a fake acceleration. So this fake acceleration will be because of fake force. In reality, force is not acting on this. There's a fake force. And this fake force is what we call the pseudo force. Sir. So my logic says this pseudo force will only act when the observer has some acceleration, 100% correct. So if observer does not have the acceleration, then pseudo will not act, 100%. And this is what we call inertial frame. Inertial frame. And this is what we call non-inertial. Non-inertial frame. Means, sir, non-inertial frame means when the observer is in the accelerated frame, when it has acceleration. And inertial frame means when the observer is either at rest or it is moving with the constant velocity. So only in that particular case, we say this pseudo force is going to act on the object. And one more important thing I just want to say. If acceleration of the observer is towards left, towards right, you see pseudo force on the object is acting towards left, just the opposite. Just the opposite. Yes. So this acceleration of the block according to C is fake acceleration, which is due to the fake force called pseudo force. That is what I am saying. A and B are in the inertial frame because velocity of A, velocity of B, A is 0, velocity of B is constant. That's what I said. Velocity of C is called the non-inertial frame. C is in the non-inertial frame, and pseudo force acts only when the observer is in the non-inertial or accelerated frame. Everything is mentioned over here. Sir, for the first time, I am understanding the pseudo force properly. I hope so. I hope so. Now, let me give you the crystal clear feel. Take a look over here. Take a look over here. See. Find the normal force on the mass M placed in an elevator accelerating upwards. Accelerating upwards. See, there are two ways to solve this particular question. There are two ways to solve this particular question. The first is inertial frame. The second is non-inertial frame. Take a look. Lift. This is the lift. Block is placed inside the lift. On the lift, On this block, first and the foremost thing, guys, let's suppose if we place the observer inside the lift. Now, if the lift goes up with an acceleration a, the person will also go up with an acceleration a, means observer is in the non-inertial frame, accelerated frame. When observer is in the accelerated frame, okay, then we say in that case, pseudo force will act on the block. See, pseudo force is acting on the block, that is m into a, F is equal to m into a. And this is mg, that is mg. And in the upward direction, this is normal. Now tell me guys, you will be applying pseudo only in that case in which observer is in the accelerated frame. Put the observer inside. Cool, sir. Now tell me, my dear NEET aspirants, when the observer is looking at the block, when observer looks at the block, according to the observer, he says block is at rest. We say according to the observer, block is at rest. If according to the observer block is at rest, means upward force is equal to downward force. This n will be equals to, normal reaction will be equals to, that is mg, I would say, plus ma. So n will be equals to m into g plus a. This is the solution of this question using inertial frame, non-inertial. Now put the observer outside, out of the lift. Now this is in the inertial frame. Now tell me, if the observer is in the inertial frame, will the pseudo act? No. See, I have not applied the pseudo. Now only two forces will act, normal reaction and mg. And in this case, we'll be use second law. Why? Here, why couldn't we use the second law? Because according to this person, block was at rest. Upward force is equal to downward force. But right now, according to this person, he sees this is accelerating upward with an acceleration a. So this block is also accelerating with an acceleration a. Now in this case, we say net force is equal to mass into acceleration. Net force means upward force minus downward force. N minus mg is equal to mass into acceleration, m into a. Now take it over here. N will be equals to, that is ma plus, I would say, mg. So n will be equals to m into g plus a. Sir, we are getting the same answer with this also. Yes, absolutely. Yes. Sir, if we do not apply pseudo over here, then we'll get the wrong answer. Yes, in that case, we'll only get n is equal to mg. So my dear NEET aspirants, so when the observer is in the inertial frame, we apply the pseudo. Let me show you one more. This will take the confusions out of your mind. Find the normal force on the block, on the mass m placed in an elevator going accelerating downwards. Okay. Guys. Put the observer in inertial frame, non-inertial frame. Okay. Non-inertial frame means accelerated frame inside. Now see, if you are putting the observer inside, lift is accelerating downwards. Acceleration of this is downwards. So pseudo will act in the opposite direction, up. Now according to this person, block is at rest. According to observer, block at rest. So upward force will be equals to the downward force. So upward force will be n plus ma, downward force is going to be mg. So n will be equals to mg minus ma. So n will be equals to m into g minus a. I hope everything is crystalline clear. Sir, solve the same question using non-inertial frame. Put the observer in inertial frame. Now, if the observer is in the inertial frame, means outside. So according to this person, this lift is accelerating down. So block is also accelerating down. So pseudo will not act. So we say use net force is equal to mass into acceleration. Pseudo will not act. Ignore the pseudo. So net force is mg minus n. That is mg minus n, because it is going down with an acceleration, is equal to m into a. Take it over there, take it over there. So this is mg minus ma is equal to n. So n will be equals to m into g minus a. Sir, we are getting the same answer. We are getting the same answer. Yes, we are getting. Sir, which one should we follow while solving the question? Inertial or non-inertial? I would say you go with the non-inertial frame. Apply the pseudo, balance the forces, done and dusted. Apply the pseudo, balance the forces, done and dusted. Please tell me in the chats how many of you understood this. Everybody out there. Quick, 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 quick. Quickly, guys, tell me in the chats. That's great. Take a look. The mass of a lift is 2000 kg when the tension in the supporting cable is 28,000 Newton. Then its acceleration is. This is the lift. Okay. And it says tension in this supporting cable is 28,000 Newton. Okay. And mass of the lift is 2000 kgs. 2000 kgs. Okay. Then its acceleration is. Tell me, guys, quickly in the chats. Tension in the cable is given. Okay. And we are supposed to find acceleration. Come on. Simple question. Very simple. Quick. Tell me. Tell me. Solve the same question using non-inertial frame. Guys, put the observer in non-inertial frame. That's it. Put the observer inside. When you put the observer inside, its acceleration is given by. When you put the observer inside, see guys. This is the tension, this. I would say this is the acceleration. So can I not say in that particular case, we say pseudo will act in the opposite direction. This is the acceleration over here. This tension is acting. And in the downward direction, I would say this is m into g. This is m into g. Now tell me, if you are putting the observer in the accelerated frame, so this person feels I'm at rest because he himself is in the lift. So upward force tension will be equals to the downward force. That is mg plus m. So this tension, okay, this is, I would say in this particular case, 28,000, and mass you can take common, that is 2000. Then g plus a, m you are taking common, g plus a, n plus a, 3 zeros, 3 zeros. This is 28. 2 ones are 2 14s are. So this is 14 is equal to 10 plus a. Okay. So this is 14 minus 10 is equal to A. So A will come out to be 4 meter per second square. Is that clear? Is that clear? A man weighs 80 kg. He stands on a weighing scale in a lift. You have got a lift over here. Okay. And there is a weighing machine inside the lift. And the man stands on the weighing machine. Okay. And its mass is 80 kg, which is moving upwards with a uniform acceleration. This is moving upwards with an acceleration of 5 meter per second square. What should be the reading of the scale? Reading of the scale means what will be the normal reaction. He's asking the normal reaction. See guys, put the observer inside the lift. Now when you are putting observer inside the lift, see, on this person in the upward direction, normal reaction is acting. And in the downward direction, we say mg is acting. And if it is going up with an acceleration a, we say pseudo will also act in the downward direction, that is ma. Now, with respect to this person, this is at rest. So we say N, upward force will be equal to downward force, mg plus I would say ma. Normal reaction in this case will be m into g plus a. So this normal reaction will be mass is 80 kgs, g is given as 10 and acceleration is given as 5. I hope this is crystal and clear. So this is 80 into we say sir 50. Oh, clear? Oh, that is 1200 newtons. 1200 newton. Okay, so this comes out to be equal to 1200. If a trolley accelerates horizontally with an acceleration a, then Bob is displaced backward from its initial position, the angular displacement. See guys, there is a trolley over here. Okay, there's a trolley, there's a trolley, and my dear NEET aspirants, there is this bob, there is the string and a bob is attached to this trolley. This trolley is moving and with an acceleration a. Okay, yes. Now when this trolley moves with an acceleration a, put the observer inside the lift. Don't you think that pseudo force will act on this? So because of the pseudo, what I can say, when this trolley moves with an acceleration a, so it will go backward and it will create an angular displacement theta. We are supposed to find the value of this theta and tension in the string. Tension in the string. Now, my dear NEET aspirants, it is obvious when the trolley moves forward. Okay, so this is going to move in the backward direction. Why? Because we say pseudo will act in the backward direction. Mass into acceleration. This is observer, pseudo will act backward. And what is the force acting on this in the downward direction? That is m into g, mg. And in this direction, in this one, you have got tension T. And if this is theta, my dear NEET aspirants, this is going to be theta. This theta. So this will be T cos theta. And this is going to be T sin theta. What does the question say? The angular deflection of the bob in equilibrium will be. So basically, when this bob moves backward, it remains stationary, it remains in the equilibrium. Then you have to tell me how much is the value of this theta. Now, what I am supposed to do, whenever you see the word equilibrium, you balance the forces. So we say bob in equilibrium. Bob in equilibrium. What does that mean? Upward force, downward force. This force is equal to this force. So that means T sin theta will be equals to MA and T cos of theta will be equals to MG. So upward force, downward force, right force, left force, divide, divide. T and T will cancel. Sine theta by cos theta is tan theta is equal to M and M will cancel. A divided by G. We are supposed to find the value of theta. Theta will be tan inverse of A divided by G. So this is this is the value of theta. And if we have to find the tension also, tension. Guys. This is the bob. In the downward direction, it is mg. In this direction, it is ma. In this direction, it is tension T. These are the three forces, mg, ma, and this T. Don't resolve this T. Now, guys, what is the resultant of this one and this one? That will this one, this R will be under root of. When two vectors are at an angle of 90 degrees, so this is going to be ma whole square plus mg whole square. Okay, and this if this is the resultant R. Now guys, if the bob is in equilibrium, don't you think that this resultant is going to be equal to tension? So this will come out to be the. Yes. Now one more important question over here. What horizontal acceleration should be provided to the wedge? This is what we call the wedge. This is what we call the wedge. What horizontal acceleration should be provided to the wedge so that the block of mass m, there is a block of mass m placed over here. There is a block of mass m placed over here. There is a block of mass m placed over here. Remains at rest with respect to wedge. Basically, it says that what should be the acceleration of this wedge so that it does not skid down. So that it does not skid down. It's a good question actually. See guys. It will not skid down when upward force will be equals to the downward force. As simple as that. When forces are balanced. See. If this is theta, what is the force acting on this? This is mg. Okay, this is mg. Now tell me guys one thing. This will be, if this is theta, we know this will be theta, and this is going to be mg cos theta. And in this direction, it is going to be, that is mg sin theta. Yes, sir. Now guys, listen carefully. Put the observer inside, because we solve all the questions with non-inertial frame. So we say acceleration is forward. We say on this block, pseudo will act backward. Pseudo will act backward. Okay. Now guys, if this is ma, this component, if this is theta with the horizontal, this will be also theta. And this component is going to be ma cos theta. Because if this is theta, this will be ma cos theta. Now guys, the block will not slide down only if the upper force ma cos theta will be equals to mg sin theta. Block will not slide down only if, I would say, ma cos theta is equal to mg sin theta. This and this will cancel. So take it over here. A will be equals to g. Then we say sine of theta divided by cos theta. Sine theta by cos theta is tan theta. A will be equals to g tan theta ma cos theta. Theta. This is cos, this is sine. A is equal to g tan theta. Is this clear? So this is the acceleration at which the block will not slide down. Tell me guys, is this clear? Ladies and gentlemen, tell me. Guys, give me the signal in the chats. Is this clear? What acceleration should be provided? What acceleration should be provided to the wedge so that the block of mass m on the wedge falls freely? Falls freely. Guys, imagine there is a table over here. Imagine there is a table over here and there is a block placed on this table. Okay. Now, my dear NEET aspirants, imagine if I ask you, see. This is a table and there is a block placed over here. There is a block placed over here. There is a block placed over here. Okay. On this table. What if I ask you to take this table little bit something like this? What is going to happen? If you take this table backward little bit, what is going to happen? It is going to fall down. It is going to fall down with what acceleration? With acceleration g. And that is what we call free fall. That is what we call free fall. And when it falls freely, in that particular case, is this block in contact with the table? No. So means in that case, normal reaction will be zero. Oh, crystal clear concept. So when an object falls freely, what does that mean? It is not in contact with any other surface, means normal reaction is zero. Means normal reaction is zero. Same concept we apply over here. If the wedge, see, let's suppose if we are pushing this, what should be the acceleration with which we need to push this so that this wedge falls freely? We say wedge will fall freely when normal reaction becomes zero. When normal reaction becomes zero. When it loses the contact, or when it loses the contact with the wedge. Here it is block. Block will fall freely when normal reaction becomes zero or when it loses the contact with the wedge. Now guys, take a look. See how do I solve this question. See, this is m in the downward direction. I would say this is mg. And this component over here, if this is theta, this will be theta. This will be mg cos theta. Okay. And this component will be mg sin theta. Now guys, see, if this is the acceleration a, put the observer inside the wedge. Now observer is in the non-inertial frame. With respect to the observer on this block, pseudo force will act opposite to the direction of acceleration. If this is backward, pseudo will be acting forward. Okay. Now guys, listen to me very carefully. If this is theta, we say this is going to be theta in this particular case. Okay. Now my dear NEET aspirants, sorry. Now guys, if this is MA, this will be one component. This will be another component. This will be another component. Now, if this is theta, this is going to be. Okay. Now, this is MA. This is MA cos theta. This is going to be MA sin theta. And along this only, we say normal reaction on the block will be. See guys, this is theta. There is a block over here. On this block in the downward direction, we say mg will be acting. and this will be theta, so this will be mg cos theta. Okay, and if this is the acceleration, so on this pseudo will be acting opposite. Now if this is ma, this will be its one component, this will be its another component. If this is theta, this will be also theta. Okay, it is like this. Okay, if this is theta, this will be theta. So this is ma, this will be ma cos theta, this will be ma sin theta. That's what I explained in the previous question. Or let's keep this as it is. This is ma sin theta, and in this direction only normal reaction will be there. Now guys, tell me, in this particular case, can I not say this force plus this force will be equal to this force? Upward force is equal to downward force. We say ma sin theta plus normal reaction will be equals to the downward forces mg cos theta. Now guys, since you said normal reaction must be 0, then only it will fall freely. Yes. This m and m will cancel. Yes. So a, and then we say sin theta divided by this cos theta will be equals to g. Only g remains. Sin by cos is tan. A, then we say tan theta is equal to g. So acceleration will come out to be g divided by tan. So if this is the acceleration of the wedge, then block will fall freely. I hope this is crystal and clear. We are finally done with the laws of motion, First chapter done. Let's move on to the next chapter, that is friction. It will take us 1.5 hours. Shukriya. Wasim sir. Now guys, friction. Let's move on to this particular chapter, friction. Friction is something which opposes the relative motion or tendency of relative motion. Friction is something which opposes the relative motion or tendency of relative motion. Listen to me, my dear friends, how I am going to make you understand. Let's suppose there's a block over here, okay? And this block is present on this surface. This is the surface, it is present on this surface. Okay. Now, if I say you apply some sort of force on this block in the forward direction. Okay. You apply some sort of force on this block in the forward direction. We say now this block wants to move. We say with respect to this surface. It wants to go forward with respect to the surface. So this surface is going to create the friction over here. That's why we say friction is something which opposes the relative motion or tendency of relative motion. This has the tendency to move forward. So it will oppose it. So friction will be bad. Like. My dear NEET aspirants, the first point over here. Frictional force is a contact force which acts parallel to the contact surface. Like there is a block over here. If we are applying the external force in the forward direction, we say friction will be something like this backward on this block. Okay. And my dear NEET aspirants, we say it is parallel to the contact surface. It opposes the relative motion. Relative motion means this block wants to move with respect to this surface. Okay. Or tendency of relative motion. If the block has the tendency to move forward but has not moved forward as of now with respect to the contact surface. Now guys, we say due to the force F, due to this force F, block wants to do the relative motion due to this force. When you apply force F on this block, it wants to do the relative motion. But friction is opposing it. This friction is being applied in the backward direction, which is opposing it, which does not let this block go in the forward direction. Okay. So friction acts opposite to the relative motion. Now guys, if the block wants to go forward, we say friction will act something like this in the backward direction. Now see, let me tell you one important point over here. Listen carefully. Let's suppose this is a block over here. This is the velocity. This block is moving in the forward direction because direction of motion is decided by the velocity. If the block moves forward, now guys, if block is moving in the forward direction, imagine you are inside, sitting on this block. It feels like this is going in the backward direction. If the block moves forward with respect to the surface, friction on the block is backward. On this block, friction will be backward. If the block moves forward with respect to the surface, friction on the block will be backward. Also, surface is moving backward with respect to the block or with respect to the car. This surface is moving. It is like you are inside the car, and when you look out of the window, it feels like trees are moving in the opposite direction. Okay, same is the case over here. This is the car, so you are moving in the forward direction. Okay, it feels like this track is going in the backward direction. So surface is moving backward with respect to the car. So friction on the surface acts in the forward direction. On this surface, we say friction will act in the forward direction, F dash. So basically, my dear NEET aspirant, see, what I'm trying to say is that if there is a block over here, if the block is moving in the forward direction, so with respect to the surface, it moves forward. So friction opposes the relative motion. So it will apply the friction in the backward direction. Now. If let's suppose you are standing over here, with respect to you, this is moving in the backward direction. So friction opposes the relative motion. If its relative motion is backward, so it will be applying the friction on this surface in the forward direction. Okay. Is that clear, guys? It is not that Wasim sir. It is another Wasim sir. My friend. He also teaches physics in Kashmir. Okay. Is that clear, guys? Is this clear? Oh? I hope friction is clear. Now we define over here static friction and kinetic friction. Okay. Now see, what does static friction actually mean? It is the friction which acts before relative motion begins. See. Let me make you understand, my dear NEET. See. Let's suppose if there is a block over here. If you are applying a force of, let's suppose, 10 Newton, but the block is not moving forward. Why, sir? Why, sir? If you are applying a force of 10 Newton over here, still the block is not moving forward. Even if you are applying the force, because friction is acting in the backward direction. Okay. So block has not started the relative motion yet. Understand this point very carefully. Block is at rest. It has not started the relative motion yet. So we say friction is acting. So in this case, this friction is what we call static friction. Static friction. Because relative motion, it acts before the relative motion begins. Okay? It acts when the body is at rest. When the body is at rest. Sir, when the body starts moving, let's suppose you are applying the force on the body, now it starts moving. Friction will act? Yes. At that point of time, that friction is what we call the kinetic friction. Okay. So it is the friction which acts before relative motion begins. It acts when the body is at rest. And it's a self-adjusting force. Self-adjusting force means, let's suppose, if you are applying 10 Newton force, block is not moving, means in that case, friction will be also 10 Newton. Why? So this force is being balanced with this. So that's why net force is 0, the block is not moving. Let's suppose if you are applying 12 Newton force, we say block is still not in motion. So we say in that particular case, this friction also is 12 Newton in that case. That's why we say self-adjusting. Depends. If you are applying 12 Newton, here also it will be 12 Newton. Okay. Sir, if we apply 15 Newton, in that case, block will move. Yes, block will move. Then kinetic will act. As of now, I am saying. Let's suppose, I would say maximum limiting value of this is 15 Newton. Limiting value. This is called a limiting friction. So maximum value of static friction is called a limiting friction. So means when you apply 15 Newton over here, 15 Newton over here, so we say limiting friction, maximum friction will become 15. When you apply 16 Newton, in that case, we say now the body will start moving. Okay, then static will not act, then kinetic will act. We say till the body is at rest, we say static will act. And maximum value of static is what we call the limiting friction. And it is self-adjusting. If you only apply 5 Newton force, friction will be also 5. If you apply 7, friction will be 7. Till what? Till the maximum value. Till the maximum, till the limiting value. As simple as that. Till the limiting value. Now guys, take a look. It is a self-adjusting force. Okay. It is always equal to the applied force. That's what I was saying. It is always equal to the applied force. Maximum value of static friction is called the limiting friction. Maximum value of static friction is what we call the limiting friction. Okay. So limiting friction acts when the object is about to move. When the object is about to move. That's what I was saying. If this is a block, if I say value of limiting friction is 15 Newton. So this is the maximum friction that can occur over here. That is called the limiting friction. Let's suppose if you apply external force of 5 Newton. So in that case, static friction will act. We say static friction will also have the value of 5 Newton. Self-adjusting force. If you apply the value of this as 6 Newton, this will be also 6. If you apply this 10 Newton, this will be also 10. Till what? Till 15. If you apply 15, this will be 15. But once you exceed, in that case, we say body starts moving because this force becomes greater than limiting friction. Body starts moving and then kinetic friction will act. Then kinetic friction. Okay. Okay. And when it comes to the numerical value of limiting friction is mu L into N. This is what we call coefficient of friction. Mu is the coefficient of friction, N is the normal reaction. And sir, what is the formula of static friction? We say static friction will be always equal to the applied force. And this is how you can calculate the limiting value, maximum value of the friction. Okay, maximum value of the friction. Mu gives you an idea how much capable a surface is in creating the friction. Mu gives you the idea how much capable a surface is in creating the friction. Some surfaces may have the large value of mu, that is having the more capability of creating the friction. Okay. Then kinetic friction. Then kinetic friction. Take a look, guys. When it comes to the kinetic friction, we say it is the friction which acts when the body is performing the relative motion. When body moves, when the body is in motion, in that case, the friction which acts is called the kinetic friction. It is slightly less than the limiting friction. It is slightly less than the limiting friction. Limiting friction is the maximum. Its value does not depend upon the type of motion, such as accelerated motion or constant velocity, etc. It is a constant friction. Its numerical value is F mu k into n. Okay, this is what we call coefficient of kinetic friction. This is the normal reaction where mu k is the coefficient of kinetic friction. Let me make you understand this with this example. This is a beautiful, amazing example. See guys, listen carefully. Let's suppose you have a block over here. This is placed on the surface. You are applying a force F on this block. You are applying a force F on this block. Take a look at this. Now, my dear friends, let's suppose I say limiting friction in this case is 55. That is the maximum friction which can occur. Maximum value. Now, if you are applying the 10 Newton force, how much is the friction which is being created over here? Sir, till 55, static friction will occur only 10 Newton. Why? Because it's a self-adjusting friction. If you apply 10, it will apply 10. If you're applying 30 Newton, it will be 30 Newton will act as a friction. If you apply 40, 40 will be static. If you apply 50, 50 will be static. Okay, so because F static is F applied. If you apply 54, 54 will be the static friction. If you apply 55 Newton, we say 55 will be the limiting friction, maximum friction. But once you apply the 56, now 56 is greater than the limiting friction. So in that particular case, we say body will start moving. So we say from here to here, we say body is at rest, static friction will act. This is the maximum friction. And afterwards, we say friction will be slightly less than the limiting friction. Let's assume 54, then 53, it will remain constant. So then from here, I would say here body is in motion, kinetic friction acts. I hope this gives the crystal clear feel. Even you can make the graph also, graph between friction and applied force. See guys. So this is applied force, this is friction. So we say as you keep on applying the applied force is, let's suppose 10, friction is 10, static friction 10. Applied force 20, static friction 20. Applied force 30, static friction 20, 30. And this maximum value is what we call the limiting friction. Let's suppose it is 50. Okay, and then we say this limit kind after this body starts, when you again increase applied force, body starts moving. So then kinetic will act, which is constant. Kinetic is constant. I hope this gives the crystal clear feel of this. Is that clear? Guys, tell me in the chats. Angle of friction. Now, my dear NEET aspirants, take a look over here. How do we define angle of friction? See. You have got over here a block. Okay. And it is in contact with the surface. Okay. Now, my dear friends, these are the atoms of this block and these are the atoms of this surface. When the atoms of the block come in contact with the atoms of the surface, we said they apply a force on each other. That is what we call the contact force. When two bodies come in contact with each other, they create a force called contact force. When two bodies come in contact with each other, they create a force that is called contact force. And this is the contact force in random direction. Now, perpendicular component, this is called perpendicular component. Perpendicular component of contact force is what we call the normal reaction. And parallel component is what we call friction. Sir, friction is a contact force? Yes. Normal reaction is a contact force? Yes. So basically, when two bodies come in contact with each other, so we say contact force is created. So contact force has two components, perpendicular component, parallel component. This is normal and this is friction. Perpendicular component is called normal reaction and parallel component is called friction. Now the angle between normal reaction and contact force, the angle between normal reaction and contact force, it is when the object is about to move is called angle of friction. This theta is what we call the angle of friction. And clearly you can say, sir, this tan theta is perpendicular by base. That is F divided by N. That is F divided by N. That is F divided by N. F divided by N. This is the normal reaction. And what is the value of F? That is mu into N divided by N. N and N will cancel. This will be equals to mu is equal to tan theta. Theta will be tan inverse of mu. Theta will be tan in. Even you can write the contact force also. This contact force will be under root of this N square plus X. I hope this angle of friction is clear to crystal and clear to each and every single student. Now let's move on to the questions over here. Now, boys and girls, listen to me very, very, very carefully in this particular case. See, if you ever get a question something like this, find the frictional force on the block. Now you are confused whether I'm supposed to find kinetic friction or I'm supposed to find what? Static friction. If you ever get a question something like this, could you please tell me in the chats, what am I supposed to find over here? Kinetic friction or static friction? Look at the question very carefully. Hint is given. Hint is given. Look at the question very carefully. Hint is given. Am I supposed to find the kinetic friction or I am supposed to find the static friction? Tell me. Why kinetic friction? Why? Because velocity of the body is given. Body is in motion. Here, body in motion. Here, body in motion. So if I say what is the value of kinetic friction, that is going to be mu k into n. Okay. Now guys, so this will be mu k, F mu k. Mu k in this particular case is 0.6. Okay. And normal reaction, n will be equals to m into g. That is m into g. This is 0.6 into, what is the value of n? That is 20, I would say into 10. So this will be 6 divided by 10 into 20 into this 10. So this is going to be 120 newtons. 120 newtons. Okay. I hope this is crystal and clear. Now let's suppose, my dear friends, if I say, let's take a look at this. This is the force over here. Find the frictional force. See, this is force 50. This component is going to be, that is 50 cos of 37. This component is going to be 50 sine of 37. And in the upward direction, it is going to be normal reaction. In the downward direction, it is going to be mg. We are supposed to find the frictional force. Now guys, body is in motion, velocity is given. Now we can say in this particular case, let's find normal reaction. Take this block, this is the block. What is the force in the upward direction? N. And what is the force in the upward direction? That is 50 sine of 37. And what is the force in the downward direction? That is mg. Can I say upward force will be equals to the downward force? Yes. So that is N plus 50 sine of 37 will be equals to mg. Sine 37 is 3 by 5. So N will be equals to plus this is 50 into 3 by 5 is equal to mass into acceleration due to gravity, that is 50, because 5g, 5 into 10 is 50. 5 ones are 5 tens are 50. So this is 3 and 10 is 30. 50 minus 30 is 20. Normal reaction came out to be 20. Now when I say frictional force is mu k into N. So frictional force is mu k. Mu k is 0.5. N is 20. So this will be 5 divided by 10 into 20. This and this will cancel. So this will be 5 twos are 10 Newton. Is this clear? Is this clear? Tell me guys. Let's talk about this question. Find the acceleration and friction on the block. This is a very good question. Take a look. In this particular case, could you please tell me what is the net force? That is 0. So if net force is 0, body is at rest. We say body at rest. And if body is at rest, could you please tell me what is the friction acting? Friction will be 0. Now, listen to me very carefully. Because the amount of force which is acting from the right side is equal to the amount of force which is acting from the left side. Friction is 0. Even I would say acceleration. Acceleration is net force divided by mass. So acceleration will be also 0. Now guys, in this particular case, friction is 0. But, what is the tendency of friction over here? That is not 0. Tendency of friction. Tendency of friction means what can be the maximum value of friction that can act over here in this CCC. Sir, I'm standing over here. Nobody is applying the force on me. What is the friction? 0. But if somebody applies the force on me, I'll still not be able to move in the forward direction. Why? Because of friction. Because I have the tendency of friction. Okay. Now guys, so tendency of friction means what is the limiting value of friction? Mu into N. Mu S into N. Now, what is the value of mu S? That is 0.4. N is M into G. So this will be 4 divided by 10 into, what is the mass over here? That is 5 into 10. 10 and 10, 5 fours are 20. So 20 Newton can be the limiting friction over here. This is the maximum value of friction over here. This is the tendency of friction over here, but friction in this case is 0. Like in this case, find the acceleration and friction. What is acceleration? 0. Why? Because body is at rest. What is friction? That is 0. But what is the tendency of friction? Tendency of friction. What is the tendency of friction? When I say tendency of friction, that is mu S into N. So what is the value of mu S? 0.4. And N, what is the value of N? If only mu is given, you can take this as mu S. There is no problem in that. What is the value of N? That is 5 into 10. Okay, so this will be 4 divided by 10 into 5 into, we say 10. This will be 20 Newtons. Find the acceleration between the block. Find the acceleration and friction between the block and the ground. Okay. You are supposed to find acceleration and this friction. See guys, take a look. In this particular case, friction is given as 80. Force is given as 80. First and the foremost thing, let's find the limiting friction. FL. that is mu s into n. What can be the maximum value of friction? See, Fl is equal to mu. What is the value of mu s? That is 0.6. Normal reaction is 10 into 10, m into g, 10g. So this is going to be 6 divided by 10 into 10 into 10. 10 and 10 will cancel, so this will come out to be 60 newtons. So limiting the friction is 60 newtons. See guys, please understand this concept. Here, external force is 50 and limiting friction, maximum value of friction is 60. Tell me, is the body in motion or not? Yes, body will move. So here, friction is greater than limiting friction. So body in motion. Body in motion. If body is in motion, let's find kinetic friction. Kinetic friction will be mu k into how much will be the friction acting? How much will be the friction acting? So it is like mu k. What is the value of mu k? That is 0.5 into normal reaction is 10 into 10. So this is going to be 5 divided by 10 into 10 into 10. This and this will cancel. So this will be equals to 50 Newton. So limiting friction acting is 50. Let's suppose by any chance, my dear NEET aspirants, if limiting friction comes out to be equal to this, if limiting friction comes out to be equal to this, in that particular case, we say body will remain at rest. Body will remain at rest. Okay. In that case, friction will be equal to this. Body will remain at rest. Okay. Now what is the acceleration? Acceleration is the net force divided by mass. Now acceleration is the net force. Guys, this force is 80 minus how much is the kinetic acting? This is kinetic. So that is 50 divided by mass, that is 10. So acceleration will be 80 minus 50, that is 30 divided by 10. So that is 3 meter per second square. I hope you are getting the feel of every single question. I hope every single thing is crystal and clear. Find the frictional force acting on the block. Guys, in the downward direction, it is mg. And this is going to be mg cos of 37. And in this case, this is going to be the normal reaction. Okay. And in this direction, it is going to be mg sine of 37. And this is going to be the friction in this case. Okay. So normal reaction will be equals to mg cos 37. N will be equals to mg cos 37. That is 16. That is coming out to be equal to 16. So we say friction is equal to mu into n. Okay. What is the value of mu? Mu is not given here. What is the value of mu? Mu is given as 0.7 in the question. 0.7 is given as mu. So friction in this case is 0.7 into we say 16. Okay. I hope this is also clear. I hope this is also clear. Yes. Now stopping distance. An important question. I'll give you the break. Wait. Is this clear? Tell me in the chats. Tell me quickly in the chats. I'll come. Just give me a minute. Wait. Wait, guys, I'll give you the break. Wait. Let's finish this. Now, guys, if you remember the concept of stopping distance, let's suppose a car, I have told you this in the kinematics. If the car is moving and you apply the brakes, after applying the brakes, the car does not stop immediately, but it stops after covering some distance. The car does not stop immediately, but it stops after covering some distance. And that is what we call the stopping distance. And this stopping distance was u square divided by 2a. Okay? If friction was not present, if we assume the surface to be smooth, in that particular case, we say stopping distance is u square by 2a. Okay? Now, when friction is present, see guys, an object is thrown with a velocity u on a rough surface of coefficient of friction mu, then the stopping distance and time will be, guys, if the object is moving with a velocity u, friction will be acting f, and after what distance it is going to stop, we say this is the distance, stopping distance, u square divided by 2 into mu g. Mu is the coefficient of friction, g is the acceleration due to gravity. Okay, time taken to cover the stopping distance, how much time it will take from here to here, u divided by mu g. Now, JEE 2023 question, a body of mass 10 kg is moving with an initial speed 20, okay, the body stops after 5 seconds due to the friction. Find the value of coefficient of friction. Guys. Body is moving with a initial speed of 20 meter per second. It stops after distance of, t is equal to 5 seconds. Time is given. We are supposed to find the value of mu. Now tell me, my dear NEET aspirants, in this particular case, 10 kg and moving, the body stops after the friction. Find the value of coefficient of friction. You are supposed to find the value of mu. Tell me. You are supposed to find the value of mu. What can we say? T divided by u upon mu g. Because when time is given, t is equal to u divided by mu g. And in this particular case, time is given as 5. Initial velocity is given as 20. Mu, and this is 10. This and this will cancel. So mu will be equals to 2 divided by 5. This is the value of mu. Okay, that is 0.4. Like, you have this question. A car moving with 72 km per hour on a level road. So velocity of the car is 72 km per hour. When 72 km per hour is converted to meter per second, you multiply with 5 by 18. Remember this trick from now onwards. Okay? This will come out to be 20 meter per second. On a level road, is stopped after traveling a distance of 30 meters. There is a car which is moving with 20 meter per second, is stopped after a distance of 30 meters. So this is the stopping distance. The coefficient of friction between the tires and the road is, you are supposed to find the value of mu. Guys, can I say stopping distance is u square divided by 2 times of mu g? Yes. So take this over there. Mu will be equals to u square upon 2 into s into g. What is the value of u square? That is 20 square. That is 20 square is 400 upon 2. What is the value of s? 30. What is the value of g? That is 10. This. 2 into 3 is 6. That is 4 divided by 6. 6, that is 2 divided by 3. 2 by 3. Is this clear? Is this clear? Is this clear? Tell me, guys. Is this clear? Now, I need to make you understand this topic. See, guys, I need to make you understand this topic. Angle of repose. Angle of repose. What does angle of repose actually say? We say it is that angle. It is that angle after which block starts sliding down. See. Let me make you understand. Let me make you understand. See. This is a surface. This is a block. Now I am increasing the inclination. Angle is this. Angle you can see over here. Increasing. Block is not sliding down. Still block is at rest. 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 The angle at which the block starts sliding down is what we call the angle of repose. The angle at which the block starts sliding down is what we call the angle of repose. Okay. And in this particular case, this is theta. On this block, this is normal reaction N. This will be mg. This will be mg cos theta, and this will be mg sin theta. And in the upward direction, this will be the friction. This will be the friction. Okay. And my dear NEET aspirants, listen carefully. I'll make you understand this topic. We say this normal reaction will be equals to mg cos theta. N will be equals to mg cos theta. And as this friction, limiting friction, it will be equals to mu s into n. We know. And here, when the block is about to slide, block has not slided down yet. We said this force, friction, must be equal to this mg sin theta. This friction must be equal to mg sin theta. Okay. So can I not say, my dear friends, in this particular case, this FL, see, consider this equation first. This FL is equal to mu s as it is. Instead of n, I can write mg cos theta. This is equation second. Now, guys, this limiting friction came out to be mu s mg cos theta. This limiting friction came out to be mu s mg sin theta. So balance these two. Mu mg cos theta is equal to mu mg sin theta. M and m will cancel. Okay, g and g will cancel. So mu will be equals to sin theta by cos theta. So mu will be equals to tan theta. So this is called angle of repose. Directly remember, my dear friends, if somebody asks you what is the angle of repose, that angle at which the block starts sliding down, and that angle is tan theta is equal to mu s. Tan theta is equal to mu s. Case 1. Listen carefully in this particular case. Listen carefully. If tan theta is equal to mu s, if the value of this tan theta came out to be equal to coefficient of friction, we say block is about to slide. Directly remember, block is about to slide. Block is about to slide means after this block will slide. Case 2, if tan theta is less than mu s, less than coefficient of friction, then block will not slide. Block will remain at rest. Okay, keep that thing in your mind. Block will remain at rest. If tan theta is greater than mu s, if this tan theta came out to be greater than mu s, in that case, my dear NEET aspirants, we say block will slide. And block will accelerate. Block will slide and block will accelerate. And in that case, the acceleration of the block will be directly, remember, g sine theta minus mu k cos theta. Let me summarize it over here. See guys, this is theta, this is the block over here, and this is the coefficient of friction is mu. What is this? We said tan theta is equal to mu. This is called angle of repose. Case 1, if tan theta is equal to mu, block is about to slide. If tan theta is less than mu, block will not slide. If tan theta is greater than mu, block will slide, and it will have the acceleration, and that acceleration will be g sine theta minus mu k cos theta. Here is the derivation. No need to remember this. Remember this directly. A plank with a box on it at one end gradually raised about other end. Okay, gradually raised about other end. As the angle of inclination with the reaches 30 degrees. So angle of inclination reaches 30 degrees. The block starts to slip and slides 4 meters down the plank in 4 seconds. The block starts to skid and slides down in 4 seconds. The coefficient of static and kinetic friction between the box and the plank is. Okay. Now, my dear NEET aspirants, in this particular case, see guys, we are supposed to find the coefficient of friction in this particular case. It is going to take us one hour, half an hour more, 30 to 35 minutes. Okay. Now guys, what does it say? A plank with a box on it and one end gradually raised. There is a plank and one end is gradually raised. When it reaches the theta is equal to 30 degrees, the block starts to slide down. So we say, when block is about to slide, what is the value of tan theta? Tan theta is equal to mu. What is the value of theta here? 30. So this is tan of 30 is equal to mu. So tan 30 is 1 by root 3. Mu will come out to be 1. Okay. The angle of inclination of an inclined plane is 60 degree. Coefficient of friction between 10 kg block and a surface is 0.2. The acceleration of the block down the plane is, guys, in this particular case, there is an angle of inclination, means there is an inclination, there is a slope which is having, there is an inclined plane which is having the angle 60 degrees. Coefficient of friction is 0.2. First of all, tell me, what is tan 60? Tan 60 is root 3. I guess root 3 is greater than mu, because what is the value of mu? Because value of mu is 0.2. So here tan 60 is greater than mu in this particular case. Okay. The acceleration of the block in this particular cases, we are supposed to find, what is the value of tan 60? 1 by root 3 or root 3? Root 3. Yeah, root 3. So tan 60 is root 3. That is greater than mu. Then in that particular case, guys, what is the case? The case is if tan theta becomes greater than mu. In that particular case, this is the acceleration with which the block falls. G sine of theta minus mu k cos of theta. So we say acceleration is going to be G sine of 60 minus mu cos of 60. Okay. Now acceleration is going to be 10 Sine 60 is root 3 by 2 minus, what is the value of mu? That is 0.2. Cos 60 is 1 by 2. Cos 60 is 1 by 2. Okay. Check this out. It will come out to be 7.5 meter per second square. 7.5 meter per second square. Find the tension in the string as shown in the figure. Guys, mu is given as 0.7. If I say tan of, what is the value of this theta? That is 30. Tan 30 is 1 divided by root 3. Okay. And that is less than mu. That is less than mu. What is mu over here? 0.7. If tan 30 is less than mu, we say block will not slide. Block will not slide. And if block does not slide, in that particular case, tension in the string will be 0. Why? See, guys. I'll make you understand. I'll make you understand. This is a rope over here. What is the tension in the rope right now? 0. Why? Because the rope is not tight. Same is the case over here. If I say block will not slide down, the rope won't be tight over here. So now if I make the rope something like this, in that particular case, we say tension will act in the rope. Okay. It's not charger, it is cable. Okay. So that's why we say tension in this particular case will be 0. This is NEET 2023 question. This I'll give you as homework. Simple question. Basic question, simple question. Pulling force. Pulling force. Is this clear? Tell me. Pulling force. See guys, listen to me very carefully. How much minimum force should we apply so that the body starts moving? There is a block over here. We are applying the force over here in this particular case at an angle theta. How much force, minimum force we need to apply so that the body starts moving? Directly remember this. This is what we call pulling force. That is mu ng upon cos theta plus mu sin theta. Or you can write it like this also. Mu mg upon under root of 1 plus mu square. Like the question in this particular case. Find the value of F minimum so that the block starts moving. So what is the value of minimum force? Mu mg upon 1 plus mu square under root. What is the value of mu? That is given as 3 by 4. What is the value of mass? That is 10. Acceleration due to gravity is 10 upon under root of 1 minus mu square, 3 by 4 whole square. That is 3 square is 9. That is 16. So 16 minus 9. Okay. It is 1 plus mu square. 1 plus mu square. It is not 1 minus. It is 1 plus. Sorry. So 1 plus. So this will be 300 by 4 upon 16 plus 9 is 25 by 16. Root 25 by 16. So that is 300 divided by 4 upon, that is 5 divided by 4. Root 16 is 4, root 5 is 25. This and this will cancel. 5 ones are, 5 6s are, 5 zeros are. So it came out to be 60. Okay. A body of mass 1 kg, JE 2021. A body of mass 1 kg rests on a horizontal floor where coefficient of friction is 1 by. Find the minimum applied force so that the body starts moving. F minimum force. There is a body placed on the horizontal floor. How much minimum force we need to apply so that the body starts moving? So we say this is mu mg upon under root of 1 plus mu square. What is the value of mu? Body of mu is 1 by root 3. This is 1 and this is 10. G is 10 upon under root of 1 plus 1 plus mu square, that is 1 by 3, because 1 by root 3 whole square, that is 1 by 3. So this is going to be 10 divided by 3 plus 1 is 4, root 4 by 10 divided by root 3 upon root 4 divided by root 3. This and this will cancel. So this will be 10 divided by 2, because root 4 is 2. That will come out to be 5, ladies and gentlemen. Now there is one more problem. Hanging chain problem. There is this problem, that is what we call the hanging chain problem. Okay. Now guys, take a look. Take a look. This is an important problem pattern. See guys, hanging chain problem. Let's suppose there is a table over here and there is a chain present on the table. If I say how much chain what should be the maximum length of the chain that can overlong? Okay. How much chain should overlong over here so that it does not skid down? That is what we need to find out. What should be the length? What should be the maximum length that can overlong over here? So if we increase the length, then it can fall down. What should be the maximum length? This is the maximum length. X is equal to mu into L. Okay. L is the length, M is the mass upon 1 plus mu. Okay, this is the maximum length of the chain that can overlong. Okay, this is the maximum length of the chain that can overlong. Take a look. Take a look. A heavy chain lies on a horizontal tabletop. The coefficient of friction between the chain and the table is 0.25. Mu is given as 0.25. There is a table. Okay. On this table, there is a chain. Okay. This is a chain present on the table. Okay. And mu is given as 0.25. Then the maximum length of the fraction of the length of the chain that can overlong. We are supposed to find what is the value of X. Sir, value of X is, guys, what is the maximum length of the chain that can overlong? Mu into L upon 1 plus mu. We say mu into L upon 1 plus mu. X is equal to mu. What is the value of mu? 0.25 L upon 1 plus 0.25. Okay. So this will be 0.25. That is 25 divided by 100 into L upon 1 plus 0.25, 125, 1.25. That is 125 divided by 100. This and this will cancel. 25 ones are 25 fives are. So it will come out to be L by 5. L by 5. The rope lies on a horizontal table so that the part of it is hanging. Okay. Again, the same pattern of question. The rope lies on a horizontal table. The rope lies on a horizontal table. Okay. So that the part of it is hanging. Some part of it is hanging. The rope begins to slide when the length of the hanging part is 25%. If this is L, so this is 25% of L. This is x. This is the value of x given. How much is the hanging portion? 25% of the length, entire length. What is the coefficient of friction? In this case, they are asking us to find mu. Guys, let's find the value of x. So we said 25% of L means 25 divided by 100 into L. If I say 30%, 30% means 30 by 100. 40% means 40 by 100. So 25 ones are 25 fours are. So this is x. So x will come out to be L divided by 4. Now guys, we say as x will be equals to, how do we find x? Mu into L upon 1 plus mu. That is mu into L upon 1 plus mu. Instead of x, I'll be writing L by 4 is equal to, this is mu into L upon 1 plus mu. L and L will cancel. So it will be 1 plus mu is equal to, we say 4 mu. Take it over there. 1 is equal to 4 mu minus 2, that is 3 mu. So mu will be equals to 1 by 3. Coefficient of friction is 1 by 3. Then you have this truck box problem. Is this clear? Tell me in the chats. Now guys, let's take a look at this truck box problem. See. Let's suppose, my dear friends, what are the things you need to understand over here? There is a truck, there is a platform. On this platform, there is a box placed over here. Now, if the truck is accelerating in the forward direction, if this is a truck which is accelerating in the forward direction, we say pseudo force will act in the backward direction. On this, we say pseudo will act in the backward direction. Now, block wants to go backward. Now, due to the pseudo force, block wants to go backward. But friction will act. So friction stops it. So friction acts. Now, case one. When block is about to move. Now, my dear friends, in that case, we say this frictional force, this pseudo force will be equals to the frictional force. Guys, if this force will become equal to this force, block will be about to move. Why? Because if this becomes slightly greater than this, then it will move. So this is the condition when block is about to move. How do we write friction, this pseudo force? Mass into acceleration of the truck. Because pseudo force is equal to mass into acceleration of the truck. And frictional force is mu into mg. M and m will cancel. So acceleration of the truck will be mu s into g. So what is the first thing in this particular case? Guys. This is moving with acceleration A. Due to this acceleration, pseudo will act. Due to this pseudo, it wants to go backward, but friction stops it. If this is equal to this, block is about to slide. And when block is about to slide, we got the acceleration of the truck, mu s into g. Next, case 2. When block does not move. When is the possibility when block doesn't move? When friction is greater than this. Pseudo, as simple as that. So if friction, if pseudo force is less than friction, block will not move. In that case, pseudo forces mass into acceleration of truck is less than mu into mg. M and m will cancel, so acceleration of truck is less mu s less than mu s into g. So basically, when the block is about to slide, acceleration of truck is mu s into g. When the block does not slide, acceleration of the truck is less than mu g. When the block moves, in that case, this force is greater than this force. This force is greater than this force. Okay? Okay? So in that case, this is MAT, this is mu SG, this and this will cancel. So acceleration of the truck becomes greater than mu S into G. Block starts moving. And my dear NEET aspirants, see, when the block starts sliding, then I would want you guys to apply the Newton's second law. Net force is equal to mass into acceleration. What is the net force? Net force is this force minus this force. This force minus this force. So pseudo force is greater than this minus frictional force is equal to mass into acceleration. Instead of this, m into at, instead of this, mu k into mg is equal to mass into acceleration. This and this will cancel. In that case, we got this acceleration. This is called a relative acceleration. This is acceleration of the truck minus mu k into g. Why are you mentioning mu k into g? Because right now frictional force will act. Kinetic friction will act. Why? Because the block is in motion. This is the relative acceleration of the block. Okay? This is the relative acceleration of the block. And if somebody asks, this is the distance d from here to here, how much time it is going to take in falling down. This is the time in which it falls down. I hope every point is crystal and clear in this case. Take a look at this. The rear side of a truck is open and a box of mass 50 kg is placed at 3.2 meter away from one end. Okay, rear side of the truck is open, and then it says the rear side of the truck is open, 50 kg is placed at 3.2 meter away. Then, my dear friends, in this particular case, the coefficient of friction between the box is placed at 3.2 meter away from one end. The coefficient of friction between the tires and the surface is 0.2. If the truck starts from rest, moves on a straight road with an acceleration of 2.1, the block falls off the truck after a time. See. What does the question say? There is this truck and there is a block placed over here. This distance S is equal to 3.2 meters. It says how much time it is going to take in falling down. So time taken by the block to fall down, this is A relative over here. That is how much time it is going to take? Sir, time is under root of 2d divided by A relative. And if you see, when can the block fall? Condition number 3, this, when pseudo force is greater than frictional force. And in that case, relative acceleration is equal to this. Acceleration of the truck minus mu k into g. Acceleration of the truck, we say as acceleration of the truck minus mu k into g. This will be equals to A relative. Now guys, A relative is equal to, what is the acceleration of the truck? Look at the question. Acceleration of the truck is 2.1 meter per second square. Okay. And what is the friction? That is 0.2. So I'll write over here 2.1 minus 0.2 into G is 10. So 0.2 into 10 is 2. So 2.1 minus 2, that will be 0.1. Okay. Now guys, this time will be under root of 2. What is the value of D? This D distance is given as 3.2 divided by A relative, that is 0.1. Oh, yes or no? This will come out to be 8 seconds approximately. Check out from your end. I hope this is crystal and clear. Then you have, in this case, vertical truck box problem. Vertical truck box problem means if the block is present over here. Okay. Now the question is, there is a block present over here vertically. What must be the acceleration of the truck so that the block does not fall? With what acceleration truck should move so that the block does not fall? See guys. When block is attached to this, from this side normal reaction will act. And acceleration of the truck is forward, so pseudo force will be acting in the backward direction. And in the upward direction, we say friction will act. In the downward direction, we say mg will act. What do you think? If this friction becomes equal to this mg, block will not fall down. Okay. So we say when friction is equal to mg, block will not fall down. And in this particular case, n is equal to mg. Sorry, this is friction is mu into n is equal to mg. Okay. And this n is forward, m pseudo is backward. So this n is equal to m into at. Instead of n, m into at. M and m will cancel. So acceleration here will be g divided by mu s. This is the acceleration with which the truck should move. Then the block will not fall down. Or you can say acceleration of the truck must be greater or equal to g divided by mu s. Then the block will not fall down. Everything is mentioned here in detail. You can read it out from your end on also. Now take a look at this. Minimum force. Minimum force. See guys, this is the block over here present on the inclined surface. If I say, if tan theta is greater than mu, if tan theta is greater than mu, we say in that case block falls, block slides down. Everybody knows. Now, what minimum force we must apply so that the block remains at rest? If I say on this block tan theta is greater than mu, then the block will slide. Now, what should be the minimum force applied on this block which holds the block so that it does not skid down? This is the minimum force. Mu mg sine of theta minus mu cos theta. Done, sir. Case 2. If mu is greater than tan theta, okay, then what should be the value of minimum force so that the block does not, so that the block moves down the inclined plane? Okay. Okay. Now guys, if mu is greater than tan theta, if mu is greater than tan theta, okay, if this is case 1, what is case 1? Yes. Case 1 is if tan theta is greater than mu. If tan theta is greater than mu, block will fall down. Now, my dear friends, second case is opposite. If mu is greater than tan theta, okay, means block will not slide down. Block will not slide down. If mu is greater than tan theta or tan theta is less than mu, block will not slide down. Now, in that case, what should be the minimum force that we need to apply? Okay, what should be the value of force minimum so that the block moves down the inclined plane? Okay, so that the block moves down the inclined plane. This is the minimum force. Guys, this minimum force holds the block so that it does not fall down. This minimum force pushes the block down so that it falls down. Case 3. if mu is greater than tan theta, block is at rest, then with what minimum force we must apply so that the block moves up the inclined plane. Now guys, see. If let's suppose mu is greater than tan theta, block will not slide down, block will remain at rest. Now what should be the value of F minimum in the upward direction so that it moves up? It moves up. Three different cases. This is the value. Mg sine theta plus mu cos theta. Let's take a look at the question. A body of mass 10 kg is lying on a rough inclined plane of inclination 37 degrees. Okay. Inclination is 37 degrees. And mu is given as 1 by 2. The minimum force required to pull the body up the inclined plane. So how much should be the minimum force to pull the body up the inclined plane? Case 3, because in case 3 we are pulling the body up the inclined plane, that is mg into sine theta plus mu cos theta. So this F will be equals to mg into sine theta plus mu cos theta. So F will be equals to, what is the mass? Mass is 10. So this is 10 into 10, 100. Then sine of theta, sine 37. Sine of 37 plus what is the value of mu? That is 1 by 2 cos 37. Cos of 37. Just put the values. Sine 37 is 3 by 5. Cos 37 is 4 by 5. Guys, please tell me in the chats if this is clear. Everybody out there. Yes, it will come out to be 100 Newton. Okay. So 100. This is 3 by 5 plus 1 by 2. This is 4 by 5. This will come out to be 1. Guys, is this clear? Please tell me in the chats. Tell me, everybody. Rough and smooth inclined plane. See, there is a concept over here. What is that? This is a smooth inclined plane, theta angle. This is a rough inclined plane. Friction is present, not present. If the time taken by the block to go down on a smooth inclined plane is n times the time taken by the block on the rough inclined plane. Guys, if we release the object over here, it skids down. If you release, it skids down. Here it is going to take more time. Here it is going to take less time. Why? Because the surface is smooth, surface is rough. Now, how much is the time? We say time taken by the block on the rough surface is n times of time taken on the smooth surface. Then in that particular case, if we say this, then we say this mu, coefficient of friction will be n square minus 1 divided by n square into tan theta. This is the coefficient of friction of the rough surface in that particular case. If somebody says time taken on the rough surface is n times of the time taken on the smooth surface, then this will be the coefficient of friction. Like. This is the question. A body slides down the inclined plane of the inclination 30, takes time twice as great as the time taken on slipping the identical frictionless plane. In this case, this is a smooth plane, this is a rough plane. So it says time taken on rough surface is 2 times time taken on smooth surface. Okay, and what is the value of n in this case? 2. Then the coefficient of friction between the body and the plane is, says coefficient of friction between the body and the plane is, that is n square minus 1 upon n square minus 1 upon n square into tan theta. Theta is 30. So mu will be equals to n square is 2 square is 4 minus 1 by 4 into tan 30, 1 by root 3. Okay, mu will be equals to 3 divided by 4 root 3. 3 divided by 4 root 3. Now, this is one more problem pattern. This is called block on block problem. Block on block problem. Two rough blocks, two rough block system on smooth horizontal surface. Find the maximum force acting on the lower block so that they will move together. Take a look, guys. Take a look, guys. I'll make you understand this. Take a look, guys. I'll make you understand this. Now, guys, see, it says that two rough surfaces, block system on a smooth horizontal surface. Two rough block system on a smooth horizontal surface. This surface is smooth. Find the maximum force acting on the lower block. What is the maximum force acting on the lower block? So that they will move together, so that the blocks move together. See, guys, if you pull this block in the forward direction, we said this block wants to go forward with respect to this block. So this block will apply the friction on this in the backward direction. Ah, amazing, sir. Call it F1. Similarly, if this block wants to go forward with respect to this M2, this M2 will go backward. It wants to go backward with respect to M1. So friction on this will be forward. Friction on this will be forward. See, if you are pulling the lower block in the forward direction, with respect to the upper block, it wants to go forward. So upper block will apply the friction opposite. Now, this block wants to go backward with respect to the lower block. So lower block will apply the friction on this in the forward direction. And in the upward direction, it is normal. In the downward direction, it is M2 into G. Okay. Now, guys, let's take this block. Let's take this M2 block. Force on the forward direction is F2. This is F2 friction. Okay. Now, guys, what can I write in this particular case? We say apply second law. Apply second law. We say net force is equal to mass into acceleration. Net force over here is F2, this friction. Mass in this case is M2. Acceleration is A. Okay. Now, what is the value of F2? Friction. Friction is mu into mg. Mu into mg. That is M is M2 into G is equal to, we say, M2 into A. This M2 and M2 will cancel. So acceleration will come out to be equals to mu G. So we calculated the acceleration over here. Now, guys, find this force. Now, this force will be equals to mass into acceleration. So this force will be equals to, this is the force which is pulling both the blocks together. So mass will be simply M1 plus M2. And instead of this acceleration, you'll be putting mu into G. You'll be putting mu into G. This is the force. So with the help of the upper block, we calculated acceleration. And if the both blocks are moving together, so whatever is the acceleration of upper block, same will be the acceleration of lower block. Like there is a question on this one. The maximum value of the force which can be applied on the system so that the figure of both the blocks move together with the same acceleration. We are supposed to find the value of this F. Guys, F will be M1 plus M2 into mu G. That is M1 plus M2 into mu G. Like here, M1 plus M2 into mu G. So what is the value of M1? 100 plus 1 into mu G. Mu is 0.5 into we say 10. This is called block on block problem. Okay. So Thank you. That's all for today. And I hope you will comment once I end the live stream. How was the session and all? Chalo guys, take care. Huh? See you guys tomorrow.